Okay, just a moment.
Okay, while you are doing that, let me do a brief introduction. Yeah, I welcome all of you, all the participants to this workshop. This workshop on space science research grants and telescope time proposal writing on this day, 28th of January 2025. Of course, this workshop came out of the need for students and researchers in Africa to learn how to write research grant proposals. And because we are dealing with space science and astronomy, telescope is a basic facility, and we all need to know how to access the telescope and make proposal on the use of the telescope. That is why we decided to put up this workshop so as to educate our students and researchers across Africa and even beyond. So this day we are going to have somehow a long program up to 3 hours, but there may be break. And the lead resource person in this, Professor James Chibeze. Professor James Chibeze is somehow a regular face on our program. And Professor James Chibeze is a professor of astrophysics at the University of South Africa. And as we all know, he's a major resource person to many telescope facilities across the world. So I think it's a good thing to have him. And yeah, we will gain from him. And once again, I thank all of you for making out time to be part of this program as we continue. So Professor James, over to you.
Okay, good. Good morning, everyone. No, it's already afternoon for some of us. Can you all confirm that you can see my screen and that you can hear me clearly?
Yes.
Yes. Yes.
Yes.
Okay,
Yes.
good. So thanks, Professor Odo, for the introduction. I would just like to tell you that I have minimized everything in my screen. I can only see the slides. So if you do want to call my attention, unmute yourself and ask me questions. And I will entertain questions while I give this talk. So don't wait till the end. If there's anything that you want to ask, unmute, interrupt me, and then ask questions. So my job today is to the best possible way explain how we do research grant proposal writing in space sciences, but I will be using examples from astrophysics. So if you are interested in things like rocketry, or rocket launches and other forms, satellite technology, it will still, things I say will still be applicable, but the examples I will use will be in astrophysics. Also, what we do in astronomy and astrophysics is to use telescopes of different kinds. How do you write the telescope time proposal? How do you request for observing time on a telescope? Happily, most of these telescopes are free of charge. Some of them you are required to pay for the time. In that case, you don't necessarily need to write a proposal. Okay, so I'll go straight into it. First, what really is a proposal? Well, a proposal is a document that you write, and in it you provide a rationale of a planned scientific research project. You provide details of the research questions that you will answer, the methods you will implement to answer those questions, the kind of result you expect as an outcome. Of course, this would not be completely, it will not always be what you expect that you find, depending on the kind of observation you do. And also the timeline you hope to execute this project. In the case of grant application, the budget that you are hoping that an agency will provide for you to be able to execute your project. And in the case of observing proposal, you seek approval from the time allocation committee to conduct source study with the instrument. Let me also note that if you stop hearing me, please, somebody should say something just in case I get interruption on my network without knowing it. So proposals can be big or small. In this case, I'm just saying there are some proposals that are called large proposals. There are also some that are small proposals, and all of them get rejected. Essentially, the fact that it's big or small does not mean it will get accepted. And proposal writing involves a lot of work. Therefore, if you get a rejection, it's like a huge amount of time gone down the drain. And this is particularly a reason that you will see me specify things like do not just write a proposal if you're not fully prepared to give it your best. So every proposal deserves your best shot. Do not start one if you haven't decided to give it the best, and make it as perfect as it can be before you submit it. Otherwise, it's nearly a waste of time. In Africa, we have what we call African time. Please, proposal deadlines are real deadlines. Don't assume that, yeah, maybe it's African time. You can actually submit the next day or an hour after the deadline and hope you will be considered. In some cases, the servers are closed on the deadline time, specific time, and you would not be able to submit. So no African time. Follow the real deadlines. So those are a few definitions and facts about proposals. Remember, I'll be running this talk in two phases. I'll spend roughly 1.5 hours or another 1 hour, 20 minutes, talk about grant proposals. This is essentially where you're requesting money to execute some kind of project. And then we'll take a 30 minutes break. I'll spend another 1.5 hours or thereabout on observing proposals. And that will be a bit more technical, but don't worry about it. I'll explain all the details. So, rejections are part of the life of every, let me use astronomer first, or every space scientist, or every scientist. And I'll give you a very renowned example. The picture you see on the top right corner is actually a picture of Carol Grida. She's a renowned American molecular biologist. And in 2009, she won the Nobel Prize. On the same day, she was informed about her being the winner of the Nobel Prize. That is same day she received the news about a recent grant proposal she had submitted in that year that it has been rejected. So it's not important. Your name, or big or small, is not important to the review committee. What is important are some of the ingredients I will highlight here, which your proposal must contain. Also, even at that, remember that you'll be competing with others. So while you may have a very good proposal, there will be, I guess, a couple of tens or hundreds of other good proposals that are submitted for the same purpose. And the funding organization will not be able to fund all of them. So they have to choose one. Whatever criteria they decide, let's say your science case is good, another person's science case is also good, and they try to find a way to break the tie on who to fund. It is totally up to the review committee to decide that. And yours could be rejected, not because it's bad. Well, of course, it could be because it's not good enough. It could also be because it's good enough, but there are other better proposals. So rejection can always come your way, and do not despair about that. I want to use an example of myself. In terms of title, there could be big names. Don't pay attention to that. I hold a distinguished professor position, and I'm also a vice president of the International Astronomical Union. But what you see in the white panel there with red lines is comment from reviewers on a proposal that I co-authored and submitted to MIACAT to observe a certain source, and it was rejected. So if you see the first red line, it says the project will not be scheduled. So it just means we will not accept this proposal or we do not accept the proposal. However, it's good thing. Remember, they say it's not how many times you fail, it's your ability to persist and keep trying, taking the lesson from every rejection, implement it and apply again when the call opens. And that's why I've highlighted the second line, which I'll read out. First part says, the following panel comments, okay, are intended to provide you with constructive criticism. We hope that they will help you improve the proposal for another future submission. So there is allowance for applying for the same telescope time in the future. So rejections will certainly come your way. However, you need to use that rejection as a way to strengthen your resolve and to improve your proposal to compete again next time. Cool. But that said, do not be the one that make your proposal good enough to be rejected. So I have written here that you should not deliberately try to break the record of whoever holds the record as a researcher with the highest number of rejected proposals. Of course, you can if you wake up 2 days to the deadline and you decide to submit a proposal which you did not get input from anybody. It's just your idea. It's not well tailored, doesn't even suit the grant or the telescope you are applying for. Then you will get rejected because it will not turn out to be a good proposal. But do not despair in this case. It's just, yeah, don't get depressed by a rejection, because if you've done a good job and you submitted, there may be multiple reasons why it could be rejected. And then if it is, in most cases, you'll get feedback that are useful for you to use to improve it next time. Okay, now I get clearly into part one, grant proposal. This is it's a very tricky kind of proposal. In this case, you are asking people for money to do certain things. The people you're asking for money may not necessarily believe in what you want to do. So it means you have to make sure that you put your idea clearly across to the reviewers who may not understand details about the kind of project you want to do. I've put it here that you should think about it as an attempt to convince a stranger to fund a project that only you know the benefits. You are the only one who understands why this is absolutely necessary to be done. For example, you want a project to build an optical telescope in a remote area in your country to use it to show people the night sky so they can get interested in astronomy and by extension in sciences, so they can take up STEM studies, science, technology, engineering, and maths. That is your idea, but the one you're asking for money could be a politician who has no idea why you would need a telescope and why you need to look at the night sky. He's more interested in giving money to people who are poor to buy food. So how would you convince such a politician to provide you money to buy a telescope and also to run the telescope? Because getting a telescope is one thing, the cost of running the telescope is yet another thing. I've given another illustration. Imagine you want to build a radio telescope, and say 30-meter class radio telescope, which will cost you around between 35 and 40 million euros. And you know Elon Musk is a billionaire, nearing almost $300 billion in net worth. How would you convince him to give him that small fraction of $40 million to build the telescope? What would you say to him? What are the costs and benefits that you provide? How would you convince him that doing this project is really essential? That is the way you reason when you want to write a grant proposal. Cool. So typically grant proposals, you don't just go to people who haven't decided to give out their money and you write a proposal and give them. For example, I don't have money to fund optical telescope in any country. So if you write a grant proposal and ask James for grant for even $1,000 to buy a small optical telescope, I'll tell you, well, I didn't put out any call for it. Grant proposals typically have calls. Calls are just advertisement for the public to apply, or researchers of certain eligibility to apply for money to do certain kind of projects. So if you're interested in writing a grant proposal, the first thing to do is to check for eligibility. You don't want to waste your time writing a proposal that takes many, many weeks and months to do. And by the time you're done with that, you suddenly read the details about the call for the submission of proposal for the grants, and you realize that you're not actually eligible. The proposal is for Americans and you are African. Okay. The proposal is for people from specific country or for a specific gender, maybe for male or for female, and then you are the opposite and you are applying for it. So first thing, look out for the call, check the eligibility. If you're eligible, one box ticked. The second thing to check before I go to the next question is actually the deadline. So let's say you're on the internet browsing, checking for grants that fund certain kind of projects, and you find one, and you realize that the deadline is in 3 hours. So the next thing to do is to ask yourself, realistically, in 3 hours, can I put together a good proposal for this? I guess the answer might likely be no. Don't say, let them remember my name. Let me put in something so they have at least seen me. Of course, that's a different case. If you have a proposal you've prepared in the past that will just need you to spend the 2 hours and polish and then adapt it to the call and submit, that is fine. But if it's starting from scratch and you are realistically sure that you cannot submit a decent proposal, I recommend skipping that stage and then maybe waiting for the call another time. The danger is that if you rush and submit a bad proposal and the call is out the next year and they have the same set of reviewers, it would have been known that you submitted the last time and you submitted a bad proposal, you probably would have made a bad impression, and that bad impression might follow in the review of your recent submission. I hope not, but it is possibility. Okay, after checking that you're eligible, you have sufficient time to do the grant proposal. One thing that could be helpful is to check what kind of projects have been funded by the funder who has put out the call for the grant proposal. So what sort of projects do they like to fund? If they don't fund astronomy projects, or they have stated in the call that they do not want astronomy in any way, they just want things in molecular biology or in pharmaceuticals or in medical sciences. Again, you don't want to waste your time submitting a proposal on space sciences that is not related to what they like to fund. So if you look through their website or wherever they provide information, and you find some successful grant application that they have published available online, please do take a look at them. Those will provide you some thought-provoking information that will help you to prepare your own proposal. One good thing to do is to consult someone who has some experience applying for the same or similar grant so that they can give you some helpful information. Here is one example, and this is, it's actually a prize, but has a grant component where you have to submit a proposal. I received an email this morning from, early this year from Michael Garrett, who is a professor at the University of Manchester. And he said, oh, look, James, I think you should apply for this Royal Society Africa Prize. And I went, wait, what is Africa Prize? I went online, went to Royal Society, looked through it, read all the information, looked at the deadline is actually still open in case you want. You can ask someone to nominate you if you feel you want to. And then I looked through the website, and then I saw this, Muhammad Ali, Ali Bakluti coincidentally is someone I've known, but he's not an astronomer. He does more of geometry and harmonics. So he was the last winner in 2024, just last year. So I looked through, of course, you can compare notes, look through what they have done, who they have given the prize, what are your chances, and if you consider it good, you just move ahead. So the information I got, beside looking through the profile of Professor Ali, the profile of the rest of the past winners, and I was happy to apply, and then I did submit for this one. So get as much information as you can, look through what the previous winners have done, as I've shown here. If you look at Professor Kelly, he's someone who does, he discovered drugs for endemic diseases in Africa. You can see Professor Novell in 2022 does tuberculosis. So again, medical field. And then Professor George is again in medical field on vaccine development. And then Dr. Steven is again biological area, discovering RNAs in parasitic plants. And Dr. Henry on HIV, TB, and HIV research. So 4 out of 6 are medical. One is biology, and then one is essentially mathematics. So I thought, okay, maybe they will consider an astronomer this time. And then I was happy to apply and submit for the grant. So essentially, all I'm saying is if you're going to apply, look through the information. I haven't shown you all the details for the sake of time, but I have also read the profile of all the reviewers because it's actually presented on the website. So I know who the reviewers are, what their field is, and there is at least 2 astronomers in the team of reviewers. Okay, cool. I have mentioned something about time. So now I'm going to outline what I consider best practices for grant proposal writing. The best thing you can do in writing any proposal, not just grant. So when I say proposal, I mean combination of observing proposal and grant proposal. So whatever I say at that point applies to the two. So in writing any good proposal, you need to start early and take your time to do it. Last minute rush is actually responsible for most rejections because when you rush, you could make some technological failures. There is also the case of rushing to submit, and then you've iterated with the proposal. You have version 1, 2, 3, 4, 5. You probably forget which one is the latest version, and you submit version 3 thinking that is the latest, and you have all the corrections in version 5 missed in what you have submitted. This is useful. I have indicated technology failure. My first job after PhD was to work as a project research fellow at the Alma Regional Center in Japan, and eventually as project assistant professor. And my job included managing proposal submission during the call for proposal for ALMA observing time. ALMA is Atacama Large Millimeter and Submillimeter Array. Is in Chile. So one of our first experiences is the first cycle was cycle 0 in 2012. And in cycle 0, 1, 2, 3 hours to the deadline, our submission server failed, collapsed. And the reason is similar to what you see in this plot. I could not find our exact plot of how astronomers submit proposals. But what you see in this plot here are the different cycles of the Hubble Space Telescope that you've heard before. And each year there is a call. The different legends represent the different calls, and the x-axis represents the time left until the deadline plus 9 minutes. Okay. Now you will see things hover around less than 20 proposals until you just approaching the 0th minute, and this will slope and just go up immediately. It simply means everybody is submitting last minute. This is bad because in some cases, like I mentioned, if the server fails because everybody is accessing it, they just maxes out the number of people who can access it at the same time, and it fails and you have not submitted yours, you'll be in panic and you may actually end up, because of waiting for the last minute, not being able to submit. So please start early. Take your time to write a good proposal. Submit it in time. Don't wait for the last minute. Don't say the deadline is still, isn't it tomorrow? Don't worry, I still have some 24 hours. No, that's not a good thing. Technology can fail you. The other reason you have to start in time is that you probably have co-investigators. Granted, you may be the primary investigator in the grant proposal, but you have others who are with you if it is grants that you're allowed to work as a team. Some grants prefer individuals, okay? So in the case of a group, even if it's individual, you probably want someone to have a look and give you input, maybe someone to proofread to make sure you have not put in a lot of typographical and grammatical errors. So account for that time you need for proofreading, for someone to have a look and give you opinion. Remember, in writing, sometimes you will be reading something different in your mind and typing something different. Okay, so, and when you proofread it, you still read what is on your mind, but what you have typed is still not correct because you're not paying attention. In your head, you have already reconstructed this sentence properly, and what you've written is totally different. Only someone else who is not in your mind will be able to find those errors. Keep in mind that just clicking submit after you've uploaded whatever you need to upload may not be the end of the submission process. Sometimes submission process will require you to first submit, and then you get a notification that requires you to do something else all before the deadline. Yeah, this is where most people struggle because they just assume that when you submit, you can go to sleep. And then you wake up the next morning and realize, oh, there is an email, but now the server is closed because the deadline is passed. And that email indicates your next finalizing step that you need to take. My last word is please don't be an astronomer in the regard of waiting to submit just the last minute before the deadline. That it's really ridiculous. But as you will see in the plot here, each of these cycle 20, 21, 22, 23, 24, 25, okay? It's the same. And it has stayed the same for all telescopes that I'm aware of, except the least subscribed telescopes that are the less popular ones. But this slope has stayed the same for ALMA, for VLA. VLA is Very Large Array, which is in Socorro in New Mexico State in the US. It has stayed the same for Hubble. It was the same for Spitzer. It is the same for James Webb Space Telescope as well. So astronomers just do things last minute. I don't know why. Please don't be an astronomer in this regard when you do grant proposals. Cool. Now let's go dissect what you require in a grant proposal and how you should put those together. First is the title of your grant proposal. Please give a careful thought to what you choose as your title. Okay. But you can only do that if you give a careful thought to the idea you want to put across as your request, as a project you want to do to request for money to do it. If you have tea breaks in your department or wherever you are domiciled, feel free to bounce this idea on your colleagues and get feedback. Discuss it with them, get some feedback. Just say, look, there's this call for this grant. I'm thinking we should ask for money to buy computers to train people to do Python programming. It's an idea. They will tell you it's good or it's bad, or if they say good, this is how you should justify your your request for such money, and so on. They could tell you, well, the amount you want to request is too much. I don't think they can fund such. Maybe request for something less for a pilot, and then maybe request for more in subsequent calls. Yeah, I think in bouncing and getting opinion of many people and putting that together, you could come up with a very strong proposal. In writing the title, it should be very clearly, the title should very clearly encapsulate the idea of the study. I will later on show you a title and you can tell me whether you're happy with it or not. As just a hypothetical title that I've extracted from the web. Okay, the title must be accurate, importantly must be unambiguous, and should be complete. Accurate means just making sure that what they're putting in the title has high accuracy, well, 100% actually. Unambiguous, if I read the title, I should not be wondering whether it's idea 1 or idea 2. It should be complete in itself. I don't need any other external addition to understand the title. If I need to make my own guess to understand your title, then it means if there are a million scientists, you need a million ideas which will vary from one person to the other in completing your title, and that shouldn't be the route. Your titles should be concise, should be convincing. I like the next word. It should be catchy and very specific. The catchy part is quite interesting because remember, your title is the first thing the reviewers will read because that's where they hope to get an idea of what you plan to do. So it should be something that when they read it, they want to know more. I've seen people use titles that are in question form. I've seen people use all manner of titles, but please note the keyword. Beside being concise and convincing, it should be catchy so that the reviewers or whoever will look at the grant proposal will be interested to see what you truly want to do. Well, that takes to the next point. It should also be appealing. You should spark interest in readers so that they want to know more. Please avoid using undefined acronyms. And of course, you don't have, because you need to be concise, you don't have all the leverage to define acronym in your title. Otherwise, it could get too long. So avoid those and please use professional language. This is slowly becoming a problem, especially in astronomy, where people, I don't know if it's the influence of social media over the years, titles are becoming less and less professional than it should be. If there are title character limits, I've seen in some cases they say 250 characters. Please be sure to obey those requirements or follow the limit rules. Cool. That's it about the title. Now we need to discuss. I picked up this title. Not going to say where. And the title says, On the Evolution of Seyfert Galaxies, B.L. Lacate. This is the title, okay? I have not removed one later. I have not added any one later. And I want this to be a 5 minutes discussion. People can raise their hand. Please just tell me, what do you think? What is your view of this title? So I've gone off full screen so I could see if there is anybody who wants to comment. We have 5 minutes to do this. Oops. Are people hearing me? Everybody has gone quiet.
Yes, we are you.
Okay. Opinions on this title. I see chat messages. Patrick.
I think the title is somehow ambiguous. on the evolution of the Seyfert galaxy, and also it contained a technical term and some acronym BL, like, and a technical term like La Cetai.
Okay.
Yeah, that's my observation.
So it's ambiguous. You really cannot tell what exactly. What else?
Yeah, it's not
opinion?
specific.
Yes, not specific. Isaac?
I followed what he was trying to say as well. The evolution of Seyfert galaxy. So the question is, what about the evolution? What is it?
Okay.
Because
Thank you.
it's quite involving just reading the first part. You may not know what is the writer really looking for in the evolution of the galaxy, Seyfert galaxy.
Okay.
Because there
Nice.
have been many things or many studies many titles that can be made from it.
Thank you. Just before we continue, Professor Odo, is this being recorded? Please.
Yes.
Okay, please, I would like to have a link to the videos afterward, because some could not join and they asked me to get the video for them. Okay, thank you very much, Isaac. Julius?
Yes, sir. The title is more of a research title, not I'll still be Hello?
Okay. So you say it's more of a research title.
Like journal, like a work you're to submit to a journal, stuff like when you are done. But it's not catchy when it's intended for a grant. Yeah, I think. And then based on what the two persons earlier have said, I agree with them.
Okay. So, well, does it mean when you go to journal, you can use non-catchy titles, Julius? Is that what you mean?
Not really, but I've come across many papers that carry such titles, so that's why yeah.
Okay. Okay, cool. Any other opinions? We still have about a minute. Good. So if you assume this to be the title of, now I need to minimize this again. I don't see any other hand, so I guess I can continue. If this by any chance is a title of a research proposal that wants money or wants to be funded, one thing you can say, as people mention, is there is ambiguity. You need to add something to that title for it to become complete. Even if it's a research paper, the title does not seem to encapsulate the idea of the results in the paper. And at least in my opinion, the title is not appealing. It doesn't spark any interest in me to read the paper. So I agree with others who say this is a bit ambiguous. Okay. Cool. Now I go one step further to background of the proposed study. This is crucial. A lot of people don't pay a lot of attention to this. Your reviewer, if you're writing a proposal that is astronomy related or grant proposal that is astronomy related, your reviewer may not necessarily be an astronomer. So do not carry all the technical, beautiful, fancy ideas of what you want to do and dump on them without first providing them the background of what is known, and moving from generally what is known to more specific of what is known and what is the knowledge gap. Okay, this is what you do in the background of the study. Please do not make the assumption that the reviewers already know these things. So why do you want to? They ask you to do it in 4 pages, therefore you will skip some other things that you feel is common knowledge. What is common to you as an astrophysicist may not be common to the reviewer, who may be not even from sciences. Okay, theirs is to just look at this and find it interesting. Please clearly present the current state of the field. By current state, what has been done in the past, what is new. Don't show any deficiency in presenting current state. I've had a couple of professors ask students, wait, why are you citing only papers from the 1970s? Does that mean there is nothing else done in this field in the late in the 2020s? So please always, of course, you can chronologically present what were initially the thoughts and what newer results shows to be the current thoughts and so on. The crucial part is that you present the knowledge gap. This knowledge gap is how you point to the reviewers that there is need for what you plan to do to be done. So if you present your background as if everything now is known, it is how do the Kenyans say it? It's uhuru now. So there is nothing else to be done. Then you've already killed your proposal on arrival, because now you've said they have discovered everything that needs to be discovered. So why waste your time? So present what the knowledge gap is. If you don't, the reviewers will struggle to rationalize why you need to do that, because there's no gap in existing knowledge, which you have stated. Therefore, why do you want to do that? If there are preliminary data to prove that there is gap in our knowledge, please present it. Let me use an example. If you think that the reason for climate change is because the ice in the poles are melting faster, well, melting at a pace that is faster than the pace at which it was melting 40 years ago. Present preliminary data to support the idea that you want to see if this rate will actually accelerate in the next 5 years, if that is what you want the grant funders to fund. Okay, there are already some existing data that there is melting of this ice. If you can present that and now propose to monitor this for another 5 years with higher precision as your proposal, and then you need money to fly to the site, you need equipment and blah, 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 and then you put that down together, but include your relevant preliminary data. In writing the background, this is really critical. You piece your reviewers off if you just present your ideas randomly. Or if you start from specific of what you want to do, it's like a triangle, okay? The triangle should have a flat top and then narrow down to specific. So it's broader at the top and then specific below, okay? If you invert that and start from specific and start broadening downwards, most reviewers will get pissed off. Yes, it's still organized, but it's written the inverted direction because they need to understand the general things first, general knowledge, and then they come down all the way down to the specific thing you want to do. I typically get pissed with people writing the opposite direction myself. So apply the general to specific style of writing. Please end that section or that the background with what your study would do. Okay. Again, don't write it the opposite direction. Don't state what your study would do before you state the general information and to the specific, and bring out the knowledge gaps and state you've stated the study before stating why the study is important. That's a bit on the reverse direction. Okay, next thing is the aim of the proposed study. This is where lots of people who write proposals, including senior scientists, make a lot of mistakes. Aim and objectives are not the same in proposal writing. The aim is the overall aim of the study you want to conduct, what that you're asking money to conduct. The objectives are the components of the aim split into small chunks. So if you take multiple chunks of your objective and combine them together and they answer a specific scientific question, then that combined objective becomes the aim. So if you can put out that one sentence that combines all the objectives you have, that is the aim of the study. Now, in scientific terms, it's usually easier if, for example, in astronomy, you put out what your research questions are. So if you pen down 4 research questions or 10, and all the research questions, could solve one problem or answer one major problem we have in astronomy, that problem becomes the aim of your study, and then the research questions you put out becomes the objectives. Okay, so I'll use an example. I have a postdoc who will be trying to reproduce a 3-dimensional map of our Milky Way. Now, if you see pictures of the Milky Way, you see it in 2 dimensions, either in longitude and latitude, galactic longitude and latitude, or in right ascension and declination. And you see distribution of the spiral arm. But the galaxy is in 3D. Okay, it has a thickness. So it means that if the stars you see embedded in a map of the Milky Way, you measure the distance from the sun, they are not all in this plane, right? So you have a galactic disk. So if you can pin down the positions of each of the stars and measure the distances from the sun, you can actually reconstruct the 3-dimensional map, like make a 3D that you can flip around and see the thickness and everything, and make it very accurate if you have the accurate distances. So to do that, if your research study aim is to reconstruct an updated 3-dimensional map of the Milky Way, you will have some objectives. What are the accurate positions of stars within the galaxy? How do I trace the positions, or how do I measure the positions? Well, you probably need parallaxes. Now, if I get parallaxes, how do I get them? You need masers. How do I get the masers? So if you break down these questions, those becomes your research questions. And if you get answers to all your research questions, you will achieve your aim for the study, which is essentially to get the 3-dimensional map. So please do not confuse aim and objectives, and please keep them separate. It helps reviewers understand what you hope to achieve and how you hope to split what you want to achieve into small chunks of small blocks of research questions and respond to them. Here is one example. In this case, this is not a grant proposal, but the aim of the proposed meerkat observation, for example, if you're going to put long sentences, remember, reviewer may be reading your proposal the last and may be very tired and is no longer reading between lines. The moment I opened this, I could tell that most of you saw the bold fonts first. And the first bold font is aim of the proposed study. The next one say aiming to elucidate mechanism of molecular cloud formation linked to star formation and the heating process of diffuse X-ray. You can already see the aim of the study, even without reading that paragraph in full. Now, if you go down, you'll see another outlined bold font, which says summary of detailed science goals. Here is called science goals, but you can just think about it as research questions or objectives. And one of them is observational characteristics of collision. The other one is estimation of physical properties related to collision. And the other one is to compare whatever you observe with carbon monoxide data. There are objectives, okay? You can change these to questions. What does H1, because the observation is to observe neutral hydrogen, what does H1 morphology look like compared to carbon monoxide morphology? You can put this however it suits you, but please remember to use professional language and be very precise, and don't confuse your reviewers. So the first bold font at the top, aiming to elucidate blah, 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 is the aim of the study. The SG123 actually is up to 5. I think 5 or 6 are actually the objectives of the study. My suggestion is to keep them separate. Don't lump them together and then get the reviewers confused about what you specifically want to do. Okay, so I've already mentioned this example. I don't know. Maybe I shouldn't skip discussing it because I'm slowly running out of time. I have just 38 minutes to stop the first part. Okay, this example, please think about it. Okay, I have mentioned that you may need masers and so on. If your aim is to reconstruct an updated map of a three-dimensional morphology of the Milky Way, what are the possible objectives that you may have? If you think about it carefully and you have answers, please type it in the chat so that people, so I don't have these 5 minutes to give away anymore. I'm sorry. Cool. So the next thing is your methodology. Remember, the title of this section must not necessarily be methodology. It can actually be simulation. In some cases, it can be the observations you hope to carry out. Yeah, it can be anything, but remember, the key idea behind this section is that it is the method through which you achieve the goals of the proposed study that you are requesting an organization to pay for. So if you have put out your aims, your objectives, and you did not state to the reviewers how you hope to achieve them, then that effort in putting out the aims and objective is useless, because you are leaving the reviewers to judge, well, is this achievable? If it is, how? They may think it's achievable, but how will it be achieved? They may not know. So please, it is absolutely necessary for you to clearly explain the method you are going to use. Be careful. As I said before, the reviewers may not have as much technical skills as you. So if you're putting out your methodology, please explain them clearly. And there are cases when it's unavoidable to use some technical terms, but please explain the technical term or use it sparingly. I've stated here that the method should be easy to understand, should be detailed enough to be convincing. If you don't provide the necessary details required for somebody to understand and get convinced about the method you want to use, you might run into trouble of people thinking, no, this project maybe is not doable, or this method is not capable of achieving the results these people are expecting. It's common in Africa to find shortcuts, but I'll tell you in grant proposals that you should completely avoid it. Justify any method you've chosen, especially if there is an alternative. So the reason for this is that there are, I don't know if it's an adage or what people just say. So there are many ways to kill a rat. You could set a trap and put a bait, and the rat comes in, activates the bait, activates the trap, and gets caught. And in this case, if you go to the trap early enough, the rat will still be alive. So you can choose to catch the rat alive. You can also poison it, look for what it likes to eat, maybe fish, and then spray poison on it and keep it for it to eat and die. Well, in the second case, you probably find a dead rat well, you run the risk of the rat after eating it while it's still alive running to a place that is inaccessible, dying there, and probably becoming a nuisance and producing foul smell from the rotting body. So yeah, there are many alternatives on how you can kill a rat. You can also chase it when you find it and smack it around with something and kill it. Well, in that case, you run the risk of people who are animal rights people coming after you. So there are multiple things you can do. In science, in astrophysics, in space science, there are also multiple ways. You can land your rocket, as we have seen, but Elon Musk chooses to catch his own. So you don't want to land it, you just catch it mid-air. I'll use a modern example here. There are many ways to automate processes, and the recent ones is what people call machine learning. Well, let me use general word AI. And then some decide, okay, maybe you can use machine learning. And in machine learning, there are different kinds. There are supervised, unsupervised, semi-supervised, and so on. Well, there is also deep learning approach, okay, to doing same thing. So if you have chosen one of these two, which will probably lead you to same destination or similar or same result, why did you choose one over the other? Okay, why is that method better than using the other one in this case? Whether it is or not, if you have chosen one, you need to justify why you have chosen one, because that's one question reviewers will ask. Why didn't you use this one? Cool. In methods or methodology, you need to put out information about the design of your proposed study, the settings, if it's going to be something that requires huge number of data points, whether it's a huge number of galaxies or a huge number of galaxy clusters or a huge number of star-forming regions, and you have to select all these numbers, explain your sample. In explaining your sample, you need to put out the reason or the criteria you have implemented in selecting your sample. Remember that your result, in most cases, will be biased based on the criteria you've implemented in selecting your samples. For example, in sample selection, if you choose FR1 type galaxies and you use only that sample to conduct a certain study, that result will be biased to the properties of FR1 galaxies and therefore may not really apply to FR2s. Okay. Measurements, what sort of measurements or observations, as astronomers will call it, did you take? What are the results? And what sort of analysis did you conduct on the results? The result is the direct outcome of the data you've collected. The analysis is now you conducting extra kind of maybe mathematical modeling of the data or some form of extra calculation. In imaging, we use what we call moment map. Moment zero is just the integrated intensity map. You use this as a form of analysis to extract more physics out of the image. There is one consideration you should never throw away, and that is ethical consideration. This in most astronomy and space science, well, in space science is increasing now. In astronomy, it's not a lot. We don't use human data, so there is probably zero risk in doing astronomy. But in core space sciences, there could be ethical risk because now you are using airspace. You could be moving, your rocket can move from airspace of your country into the airspace of another country. What if it fails and falls in that country? What are the ethics consideration you need to consider so you don't violate, of course, some international laws, some ethical rules of how the environment should be maintained in good condition and so on. Yeah, so those should also be put into consideration, though in most cases not applicable in astrophysics. Okay, there is also the issue of budget. This is a critical aspect. Let's say you've written very nice proposal of the project you want to do. But of course, this is a grant proposal. The next thing is the money you want to ask for. In most grant call for grant proposals, there is a cap to the amount of money you can ask for. Okay. So the first thing in a budget justification is to make sure that the project you've designed will fit into the upper limit of the amount that is being offered. What do I mean? You're proposing, which country should I use? Kenya. No, Tanzania. You are proposing to put a telescope on top of Kilimanjaro because Kilimanjaro goes above the clouds, and then every night will essentially be mostly clear skies for you. So you can put an optical telescope. To get the optical telescope on top of the mountain, we're making the assumption you need to construct a road. Good. So, and the call for proposal say you can ask for up to $200,000 for the project you want to do. Granted, $200,000 may be able to get you a telescope. But will $200,000 be able to get you a road on to the top of the mountain to be able to carry the telescope up to the mountain? The answer may be no. So, not maybe actually, the answer will be no, because you probably need to build a road to the top of a 2,300 meter Gamsberg Mountain, where we want to put a millimeter telescope, is now budgeted at 10 million euros. So certainly you don't want to apply for that grant because it won't be sufficient for you to execute the project. Or at least you ask for something different or a different site where you don't have to spend a lot of money. Cool. So whatever you ask for in terms of money needs to be justified. You can write 100% fantastic proposal of what you want to do. All the reviewers think this is awesome. And then when they get to your budget justification, it's very bad. You've shown that, one, the money will not be sufficient to do this project. Two, you've allocated amounts to things that the organization probably doesn't fund. Okay, so your good proposal will be rejected eventually. Avoid sloppy handling of numbers in justifying the amount. In justifying amount, remember the total amount could be 10,000. You have to say specifically what you will use $100 to do. There'll be segment for transportation. There is equipment. You list the equipment. There is hiring an assistant who will manage the project, or project manager, and so on. What I have seen in most grant proposals is that salaries are not permitted in some of them. So please make sure you read the conditions of the grant thoroughly and include only things that the organization or the individual permits for you to fund. I can tell you there is called what we call the National Research Foundation in South Africa, and they offer grants. You apply for different grants. There are grants that allow you to pay bursaries. Bursaries are just scholarships to master's and PhD students. And there are also some that does not allow you to do that. There are some that allow you buy equipment. There are some grants that doesn't. So please be sure to read this carefully so that you don't go writing budget or putting together a budget table and justification of the budget and you include things that are not included. The worst thing you would do to your proposal is to tell the reviewers, I have not read the details of the call for proposal. Okay. And one way you can do that is to include something that violates the condition of the grant. Okay, so you've written good proposal. You've put together a very, very decent budget. I would say do not try to max out the total amount that is put out in the call. Well, one example of calls for grants received very often is the one that come from IAU Office of Astronomy for Development. I've in the past reviewed this proposal, and I thought some of them were just totally unrealistic. You're told that the OAD receives a total of 100,000 euros, and they intend to fund as much as maybe 10 or 20 proposals around the world globally. So it means if you divide that by the continent, let's say they have to do equitable distribution of this fund, it should probably not be up to maybe 1 or 2 proposals per continent. And now you submit your proposal, knowing that they have 100,000 to do about 10 proposals around the world, and you're not the only one submitting even from Africa, and then you request for 70,000 euros to do a project. The project might be good, but you've requested an amount that will mean that they can only fund 2 projects, and that doesn't go well with the distribution they want to get in terms of what they fund. So give thoughts to all these things. Be sure to read those conditions, discuss it with friends, let them give you suggestions and justify their suggestions to you, and then put in a good proposal. Okay, let me put out Professor Odo, I'm supposed to stop this session at in 22 minutes. Is that correct?
Yes, by 12:30. Yeah.
Yeah, that should be 1:30 my time. Good. I still have time for a short discussion I want to have. Okay, so here are some useful tips. Reviewers have many applications to score. Your application may be read after they have read tens of applications and they are already tired. So one tip that I know works is that you try as much as you can to make the lives of the reviewers easy. Don't say, no, it's their responsibility. You don't care. They just have to read my proposal, give me a response. Well, they are tired. They are skimming through your points, and they can't find anything catchy. And therefore, your proposal is rejected. So assume that your proposal will be read when the reviewers are tired. Make their life easier. If you have to use bold font, I have just shown you this example. I opened this, I didn't allow you read it, but I could tell that you have seen the first things you see are the lines, 5 lines with bold fonts. So that's one way you can make people's life easy. So if they are trying to skim, they can almost very easily catch the point you're trying to make. Be clear, be precise, avoid complicated language. Reviewers are not interested in your English or grammar skills. So I recently almost chastised a lawyer who was trying to use complicated language. I say, if you try to communicate with people and you're speaking big grammar and mixing Greek word and English word together in order to show how learned you are, that is completely useless thing to do. Use simple language so that people can read it, understand it. You're able to pass your message. Be clear, be precise. Long sentences are abhorrent to reviewers, including myself, where you read 4 lines and you're still in one sentence. There is no full stop. That's ridiculous. Formatting can be an issue sometimes, although this is fairly cosmetic, but don't ignore it. Be sure to use appropriate formatting. Proofreading. I have time and again said this both to my students. This does not only apply to grant proposal or observing proposal. It's very irritating that somebody is coming to you complete stranger with a letter to ask you to dip your hands in your pocket and give him, and you read things that the person, even by merely reading it himself or herself, will find out that there are errors that they need to fix. So please don't make that mistake and think, oh, now I'm now very senior, therefore I don't need to proofread. I still find spelling errors in my emails. Well, maybe I can justify it because I'm just quickly wanting to respond, and the person on the other side will understand that I'm trying to throw quick response. Okay, that's probably justifiable, though wrong. But how about a proposal to ask for money? And you're giving 3 months to do it, and there is no proofreading, and it's riddled with spelling and grammatical errors. You would have, by your first paragraph, pissed off your reviewers, and they would have scored it in their brain before they get to the deeper part of your proposal. So don't fail your proposal in the first 2 paragraphs because you did not do spell checks and you did not correct grammatical errors. Proposal lengths. Call for proposals that are very kind already put limits to, they provide you limit to the number of pages. The risky ones are those ones who don't tell you how many pages you need to write. For example, observing proposals are mostly limited to 4 pages. But grant proposals are so tricky in most cases that they don't tell you how much to write. So in such cases, please be moderate. Don't underwrite. It shouldn't be too short, but it shouldn't be too long that when they flip through, they go, wait, are we reading 12 pages just for grant proposals? And they just go, oh, well, everything is stories. It looks like something copied on the internet. You may not have copied it. You may not have used ChatGPT. And they just assume that you did because it's too long. If you're doing a proposal that has specified length of pages, obey that. Whatever the policy say, please do not violate it. I'll just ask for a moment. It seems my boss is calling me. Okay. Okay, I'm sorry about that. So please keep to the rule of the proposal length. Don't assume they will be lenient in your case. So if they ask for 4 pages, give 4 pages, no more, no less. Okay. Well, you can give 3, but again, 3 might become too short. Please just be reasonable. Okay, the other thing in your proposal, which may not be directly asked for, is you showing evidence that you are capable on delivering on all the things you've said you would do. There is no point putting out the aim of your study, the objectives of your study, the method you plan to implement, without showing that you are capable of implementing all those and getting the result. We have, I use we now as a past reviewer of Meerkat's call for proposal. And then I think 2 or 3 groups have written this fantastic proposal of what they want to do. But if they are giving the full time they require, they will produce 68 terabytes of data. And they haven't provided information on whether they have experience handling Meerkat data. This data we're talking about is very huge, whether they have a cluster they can access to process this data, how they hope to produce the result within the reasonable time without just, you know, when they dump huge data on you, now you're confused about what to do next. So if you don't show that you are capable of delivering, if everything you ask for is giving, then you run the risk of your proposal being rejected. Well, one thing people do is when they write proposals, especially grant proposals, they try to invite people with big names, big institution like Stanford. You want somebody whose affiliation is Stanford University, so that maybe you think the reviewers will think that's credible enough, and therefore that means the people are capable. No, big names. Don't include my name. Don't try to include any big name. What is important is that you follow the rules of writing a good proposal, present your case properly, and in a simple way, easy to understand way. Those big names won't count. Okay.
Sorry, James.
Yes.
Can I draw you back?
Yes, please.
Yeah. On this point of where you said, are you capable of delivering? So in that case, when you are putting this kind of proposal, you need to somehow showcase the past activities you have carried out that will justify that you are able to do this one. For instance, in this research, can you go back to maybe pull one or two researches you have done in the past and the results you had as a supporting evidence to your ability to deliver?
Yes. So provided you don't run over the number of pages, there is nothing wrong with dedicating a paragraph of 3 or 4 sentences to say you've used Meerkat before and you did H1 observation, the result is published in this et al, and you process the data with EDR cluster, and the data was delivered on so date, and by so date, the data was published. That gives the reviewers an idea, okay, these people have handled this amount of data, they were able to produce a result in a good time. What Meerkat is struggling with now, for example, I'm using Meerkat case as an instance, is people write good proposals. They do the observation, generate the data, tell them, okay, your data is now stored in this archive, download it, produce the results you promised, and publish it. And they have a lot of this data that has not been published. Okay? So it means the people know what they want to do. Okay, if after 5 years of conducting an observation, the primary investigator and the co-investigators are unable to publish that paper or publish that data and show the result they got, then it means there is something lacking in their capacity to do that. It may not be the skill, maybe they have the skill, but what if they don't have the machine computing facilities to do that? So you would have requested telescope time that you're not capable of delivering on. Okay. In grant proposal, that is also the case. You have no idea of how complex an engineering project is. And you suddenly go to someone and say, well, give me $10 million. I want to build a satellite that can image the whole Nigeria and provide a map of the rainfall structure, everything that you can do with remote sensing. Well, yes, the proposal may be well written, has all the components, but the first question the reviewers will ask, wait, who is this? What is this person's background? Are they able to deliver if we give him or her this money? If you don't show evidence, maybe you're able to deliver, but nobody know you anywhere. They go on the internet, they put in the names of they find, well, this person is a postdoc somewhere, and that person is this. If you've done it before, show the evidence so that they can at least, well, that can, in some respects, sway their judgment. Okay. Don't keep them up in the air thinking, wait, can they do this? If you leave them to decide whether you can do this without evidence, the answer always comes back, we don't know, therefore we don't think so. Did I answer you, Prof. Sodo?
Yes.
Cool. This brings me exactly where I want to be, which is 10 minutes before the break. And I want to open the floor for questions on this section. Let me see the chat. What is design and setting in methodology? Okay, cool. So design is think about it as a flow chart when you write a computer program. How do you want to move from step A to B to C and get to your final destination? That's the overall global design of your project. The setting is a general word. In observational projects could mean what frequency you want to observe, what bandwidth are you going to use in the observation. Do you want narrow band or wide band? Are you doing continuum or spectral line? And how does that align with the aim of your study? Okay. Cool. I think that's all. I can now go to raised hands. Isaac.
Prof, my question is concerning the maybe consultation with others. The question is it necessary to send the document, the proposal that you have written to someone to check, for them to check so that they can give their input? If that be the case, then how do you avoid the issues of plagiarism, someone getting your information, maybe they are also interested and
We call it
use
scooping.
to apply, and maybe they are more skillful and they use your ideas to just get it. How do you avoid that?
Beautiful. That's a very good question. Yes, it's okay to send your proposal to someone to have a look and get back to you, but please, 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 only send it to someone you trust. Will not scoop. Scooping is you bring your document to this person, he gets the idea, and he delays giving you feedback, and then he submits a proposal that is essentially your idea. That is real. It happens. It happens unfortunately happens in the scientific community. So the answer to that is you should only send it to those you trust. First of all, discuss it with them, okay? Bounce off the idea, even for those you trust. Say, hey, look, I'm thinking about doing something like this. In that case, you don't have the full proposal, okay? Would he mind reviewing what you've done and giving you feedback? So if it's somebody you trust and who trusts you, and they also have similar idea, you cannot, completely remove the fact that two people can be thinking similar things, right? You may be thinking to submit this grant proposal and the person is also thinking, and your ideas, while it may not be 100%, could be up to 80% coincident. So you bouncing it first at the person and the feedback may be, yes, I'm also thinking similar thing. Or if you're doing it, since I'm thinking similar things, we can do it together. But please never send your proposal to somebody you don't know and say review, or somebody you know but don't trust. Otherwise, your idea may be stolen. Okay. Did I answer you, Isaac? Okay.
Yes.
Aman?
Good afternoon, Professor. So my first question is what is a science score, and how would saying that using simulation theory and AI to find the blue shift and red shift of galaxies in the universe be a good idea for an objective or aim? Those, I think, are my two questions.
What is
So
a science goal?
yeah, science score.
Okay, so science goal can
On your
be
proposal that you showed earlier, what's that? It was marked 7. What's that? Science score.
Yeah, so science goal is you can replace it and just say objective. Objective 1, objective 2, objective 3.
Like it was at the beginning where you said it was rejected by the Nobel Prize winner, and then there was science score 7. That slide.
Yeah.
Yeah, that's the one where it says science
Oh,
score.
okay, science score.
Yeah, what's that?
Okay, cool. So every proposal committee is giving numbers to score proposals. Okay.
Yeah.
Remember the way you say rank this from 1 to 5, where 5 is the best and 1 is the least. So this is the score of the proposal in terms of the science only. Okay.
And the thing about the using simulation and AI theory to find blue shift and red shift of galaxies to plot the expansion of the universe, is that a good objective or aim?
It could be any of the two, depending on what the global result you're looking for is. Okay. If you are hoping to use the redshift to study a different thing, then it becomes an objective. So you use simulation and redshift. You said an AI, simulation and AI to find redshift. Okay.
Yes.
If that is the final outcome of the research, then is the aim. But if that outcome is going to be used to understand something else, then it's an objective.
So when you consider blue and red shift, it becomes objective, but when you consider the AI, it becomes like an aim, right?
No, so the AI is the method.
Oh, okay.
The blue and redshift is just redshift is redshift, whether it's moving away or coming towards you. The redshift could be an objective, but if it's the final thing you're looking for, could be the aim. But if you're looking to find redshift and use redshift to understand, for example, expansion of the universe, then it becomes finding the redshift becomes an objective.
Thank you, Professor.
Cool. Edidios. Hello, Eddie. You are muted, Eddie, if you're speaking.
Yes, Prof. I'm trying to find out when it comes to grant writing proposal. You gave an example of, say, in Tanzania, you want to set up the telescope right at the top of Kilimanjaro mountain. And looking at that place, you may face some serious challenges and also there are some risks. Do you have to include in the grant proposal all those challenges and risks? Say if your grant is being accepted and then you failed to implement because of those challenges and risks. Thank you.
Yes, so I did not include it here, but if you are doing a project where you have to choose a site, you have to explain how you get the site and how you get approval to get anything done on the site. The Tanzania one is really an extreme case. I didn't discuss it for the sake of time, but you see, Kilimanjaro is a sacred mountain to the Tanzanians or the people who live in the, I think it's called Serengeti area, okay, who live around that area. So your first challenge is getting the local people to accept that you will defame their sacred place. This is already a problem, for example, in Hawaii, where there was a plan to build a 30-meter telescope on one of the mountains in Hawaii. The people decided that the mountains are their gods and they have defamed their god enough and they don't want any more telescopes. They blocked the road. They refused anybody going on top of the mountain. So yes, if there are the risks like this associated with, for example, sites or the entire project, you need to state it and how you plan to mitigate it. If the reviewers are not satisfied, you don't get the money. They'll feel it's too risky to put their money into it. If they are, of course, you don't want to select the risky sites to put your project, right? So, but if there are risks, state them. Don't try to stay silent on risk associated with your project, because if you stay silent and the reviewers spot it themselves and you have not justified how you mitigate the risk, then you may not get the time. As I mentioned, yes, in the case of Meerkat proposal, the risk is you get big data and you may not have where to store it or where to process it. And that's a huge risk. While you may be able to do it, you don't have computing facility to do it, and therefore the result may not be produced. And if we spot that risk, it even with your high score in science, we'll just say technically infeasible, and eventually the proposal will be failed. Did I answer you?
Yeah. Yes, please.
Inyama?
Very clear.
Thank you, Prof. I have two questions. One, what happens if after the proposal has been accepted and funded and it fails to produce any results? And then secondly, what's the issue? How do the ownership, or I don't know how to put it, but do the funders own the project at the end of the day, or is it a non-profit? What's the intellectual property of or rather the results? What's the property ownership of it?
Yeah.
Yes.
Okay, so
Thank
these
you.
are all stated in the call for proposal for grant. Some proposals you have to guarantee you will produce a result. There must be some fairly good guarantees. If there are small atom of doubt that this proposal may not be feasible, you will not get the money. So the reason why the review process is there is to just bring experts to look at this and make sure that if they put in their money in this, something will come out of it. So that's why the review is there. Of course, there are proposals that eventually the people receive the money. Yeah, sadly, some don't get to execute it, or the person may even pass away. These are, in most cases, stated in the terms of the grant. Okay, in this instance, if this happens, this is what you do. And some will say the money will be returned. Some will say the co-I, one of the co-Is becomes the PI and leads the project. So these conditions are provided. On the IP, yes. Universities, for example, when they fund projects, there are conditions that include that whatever intellectual property produced here is owned by the university, but the person who produces it can probably take 10% or 15% of whatever comes out of it. So those are clearly stated in the call in most cases. But if it's not stated, there is nothing wrong with writing the people funding it and say, hey, what happens? They will make you an offer of the grant and you have to sign. If there is no clarity on that and you suspect you will get some new discoveries and you want to register IP, you can email them and say, what happens if I find something and get new intellectual property out of this? Who owns it? Okay. If it's not clear, please ask. Don't sign an acceptance that you hope you bring out IP without clarifying. Otherwise, you end up in court fighting with someone. Okay. Inyama, did I answer you?
Yes, thank you very much.
Okay. Julius?
Okay, thank you, Prof. In a case where one wants to do an extensive work, so the method, for example, you intend to implement more than two, in fact, maybe up to 5 different methods into your work. So the scare is how is it that this the reviewers are going to see you to be undecisive and unprofessional, or kind of?
No. If you have 5 methods and your idea is that these 5 methods produce same results, now you want to test which one produces a result with the highest accuracy, then that is even good. That's excellent. Reviewers will look at it as very, very nice move, because it means you're going to do a thorough work and you're going to select the best outcome. Okay. But if you're saying you're going to use this and they're all mutually exclusive, they don't produce similar results, they use different assumptions, you will confuse the referees as to, wait, why are you using all these that apply different assumptions and provide different results? Which one is which and which are you aiming to produce? So yeah, I don't know if I answered you.
Yeah, it's okay. Thank you, Prof.
Cool.
Okay, Prof. James, I allow you to respond to Ogochukwu, and then we go on break, please.
Me or you respond to her?
You respond to Ogochukwu.
Okay. You guys have eaten 6 minutes into your break, just to note that, not my time.
Sorry.
Yes,
Sorry,
go ahead.
just a quick one. It's just a quick one. So you talked about the number of pages while writing a proposal. So my question now is, one, what if you have more ideas to put in that maybe if they say 4 pages won't be enough? And then two, in a situation whereby they did not really specify the number of pages that you shouldn't exceed, is there, like, from your experience, is there like standard pages, yes, like acceptable?
So if you have more ideas and the limit is 4 pages, please squeeze it into 4 pages. Write in a concise manner. Use more precision, shorter sentences, hit the nail on the head and don't run around it. Yeah, so don't say, well, I have more ideas, let me give them 5 pages. They may throw away your proposal without reading it for violating the rule that they have given out. So if you can't obey the rule, what would you do when you get their money? It means you can actually use it for something else than what you said, do something different from what the policy says. So please don't violate page limit rule of a proposal. In Alma, we throw it away. Actually, yes, in Alma, the first set of skim through of the proposal is the ones with more than 4 pages. They are first filtered and thrown in the trash before we start checking which ones to review. The second question was on the ones that they did not give you specifics. I usually say use your discretion. In my opinion, 5 pages may be enough. If you go more than 5, it starts looking a bit cumbersome to the reviewers. If it's more than 5 with a lot of figures, maybe okay. But if you have a lot of text, 5 pages is about the limits any scientist will read and still feel comfortable to continue to read, my opinion. But again, use your discretion. Okay, I guess that's the last one. Yes, 8 minutes. You have only 22 minutes for your break. I will see you all again at 2 p.m. South African time and 1 p.m. Nigeria time. I don't remember that time zone. I see people from everywhere. So it's 2 p.m. GMT plus 2. Odo, are there any other things you want to say?
No, I think it's okay. We reconvene by 1 for us and 2 for you.
Okay, are you going to stop sharing? I'll leave the meeting because I need to join another meeting briefly and come back by that time. Okay.
It's okay, we're there.
Okay, thanks. Okay. Share screen.
Yeah. Well, welcome back.
Thank you.
Thank you.
Can't see my cursor still, so go back here, turn on video. Wait. Can you hear me and see me?
Yes, very
Okay.
well.
Good. So the break is over. Welcome back. I need to minimize this. So welcome back from the break. This is a part 2. Don't panic when I show things that are a bit too technical. Feel free to ask me technical questions on this. But this part will focus on writing for telescope time. I want to believe most of you here are either astronomers or people who are
We don't
intending.
understand you.
Wait, you don't understand me? Hello? Can you hear me? Can anybody hear me?
Yes, Prof.
Yeah.
Yes, we can.
Yes, continue from
can hear
here.
you.
Okay, someone said he doesn't understand me. Please, what do you not understand?
Who complained?
Or was I the only one who heard it?
No, I heard it too.
Okay.
Okay, we can continue so long as the person doesn't show up again. Otherwise, if you didn't understand, let us know.
Okay, so please, my aim is not to cover too many materials without people understanding. So please tell me what you don't understand. You can interrupt me anytime. I'll stop and then you speak. Okay. Good. So the part 2, which I'll spend another 1 hour, roughly 20 minutes, so I can allow time for discussion to take place, will be focused on observation time proposal, asking for telescope time. In astronomy, there are lots of telescopes around the world at different frequencies. I'll show that a little bit later, just for the benefit of those who are not astronomers or who are interested in more in space science to see why we point to astronomy telescopes. The proposal for this is similar to grant proposals, except that the PI and the COIs are not asking for money. Rather, they are asking for time on a specific telescope or array of telescopes in order to observe a target. But when I say target, it's just an astronomical object in the universe, whichever one is of interest to them. The difference between grant proposal and observing time proposal is that observing time proposal are more technical, and obviously so. The telescope is a very complex piece of engineering. So you need to understand the technicalities of all the components and all the things you need to do so that you can be able to justify your proposal and get telescope time. So if you lack understanding of the telescope and how it works and at what frequencies it observes and what kind of observations it can do, then it will be impossible for you to write a good proposal. Telescope time is a very important currency to astronomers and probably to scientists. So the number of accepted proposals or telescopes from which you've secured the observation time, as I put it here, is an important currency to us. What you see below is an extract. It's a cutout from my CV, and it has a section that says successful telescope proposals. So I've secured time on the James Webb Space Telescope as a co-I. Co-I means co-investigator. I have a PI, multiple PI time on Meerkat. I've secured time on VLA and all these other instruments that are listed, which is good. So if I want a job and I show that I can write good proposals with this evidence, probably I might get the job. So it's something you need to be proud of and put in your CV. Why astronomy? Why have I chosen to do it? Well, because I love astronomy and that's what I do for a living. And this is one of those fantastic images that tell us a lot of things about our universe. There's a complex thing going on here, the background, of course, the two images of Jupiter and the background are very, very interesting. Lots of things. There are spiral galaxies, there are gravitationally lensed galaxies that have arc shape morphology. Of course, there is a Jupiter there with all the fine details that we can see from the new James Webb Space Telescope. Okay. Can you still hear me? I see my internet is unstable.
Yes, we
Complain. Can everybody?
Yes, we can hear you.
Okay.
Yes, we can.
Okay, cool. So what really is astronomy? Well, I would say it's just that fundamental science that focuses on looking or understanding our universe, which includes extraterrestrial objects like planets, stars, star clusters, galaxies, galaxy clusters, large-scale structures like filaments, and so on and so forth. Of course, astronomy can be interesting. You can do it observationally. You can also choose not to tamper with telescopes. I've shown image of the solar system, image of black hole, which everybody was excited about, image of the proper motions of stars within our galaxy, which were measured with masers, and you can see it's concentrated towards in a few quadrants in the Milky Way, which aligns with the northern hemisphere. Image of a galaxy zoo, different shapes, morphologies, and interestingly, there is the antennae galaxy, which probably I'll talk about. You can see the antennae galaxy, row 3, column 4. That's the antennae galaxy, it's emerging galaxy. That's not the only thing. I mean, you don't have to do observation or take beautiful pictures of galaxies. You can also put in initial conditions like density structures and number of particles, and then run a simulation of how, for example, in the simulation you're looking at how massive stars are formed. So that's also one way to study astronomy. You can see all the outflows and jets launch from a forming stars and how complex, of course, and beautiful the environment can be. So there are lots of things you can do in astronomy. Okay, in astronomy, this is just to bring you abreast with the basics. There are different tools we can use to study astronomy, and then that is very much related to the EM spectrum, which runs from the longest wavelength in radio up to the shortest wavelength in gamma rays. Of course, light is that narrow band in the middle, which you can spread from red to violet. Okay, good. So that's optical. So you have X-ray, you have ultraviolet, you have infrared, and you have radio, and you can study the universe in all these wavelengths. However, how you study it and where you put your telescope depends on which of the bands or which wavelengths you choose to study at. That's what you see in the blue panel. The y-axis there is height or just altitude, and the x-axis is frequency to the bottom and wavelength to the top. Of course, frequency and wavelength are interrelated. If you just apply the constant of speed of light, then you can convert from one to the other. So looking at that, anywhere you see a light shade of light blue, that means that our atmosphere does not allow emission at that wavelength of frequency to penetrate and get to us on the ground. Okay, we are on the ground. We are not 10 kilometers above the ground. So you can see that from UV, X-ray, gamma ray, we need to go to space to study it, put telescope above the ground. And that's why Spitzer telescope, well, for infrared, like the Spitzer, where you see the telescope at wavelength of 10 to the power minus 4, you can also see that is shaded. You need to go above 40 kilometers. That's 40,000 meters above the ground to do such observations. That's tricky because you have to remember that if you go higher, the higher you go in altitude, the thinner the oxygen becomes. And at about 3.3 kilometers, I think so. Yeah, at about 3.3 kilometers, you no longer get oxygen. So anything beyond that, you need oxygen cylinder. So to take a telescope up 40,000 meters is just ridiculous, even if you have the height. So it means space is your last option. You put it in a satellite, launch it in space, and use it to observe. The radio band is very clean, except anything beyond 30 meters in wavelength. So that cannot penetrate because of the ionosphere. So astronomers built telescopes to observe all these bands, okay, that are possible, including optical, which narrowly you can do from the ground. Okay. Awesome. And there are many, many telescopes around the world. I was almost going to bias against other ones and put only radio telescopes, but here is Hubble. It was originally a deep space network antenna used by NASA to do their space exploration. They use it to track their satellites and all the things they were doing with exploration in space. And after some time, it was handed over to National Research Foundation and converted to a radio telescope. That is the most functional telescope we've had in radio band before Meerkat and the rest came alive. It was built in the 1960s, actually. This is James Webb, works in the infrared band, doing his work in space, producing fantastic results. This is an array of telescopes in the US. It's called the Very Long Baseline Array, VLBA, and the antennas are located on the different territories and, well, mainland and territories of the United States. Here is PISTA telescope, it's in space. Recently, National Science Foundation of the US stopped funding this, so it was fairly, well, it went out of operation, which is sad. This is the Nobeyama 45-meter radio telescope in Japan, which I used extensively. That is the sub-millimeter array in Mauna Kea in Hawaii. This was a precursor to the ALMA telescope. Before ALMA came, this was the most sensitive millimeter array that was available. Now it's almost going out of life. I think this is the, no, I remember which one. This is the the Herschel telescope. Herschel did a lot of sub-millimeter observation, mostly in far infrared band. That's the Subaru telescope, built by the Japanese, also in Mauna Kea in Hawaii. That's our baby meerkat. And you can see me jumping on the meerkat side, violating all the rules because you're not supposed to take camera there, but they allowed us for one day to come on site visit. So I took the opportunity. Every dot you see on the map I just dropped now is where a telescope is, and those telescopes are considered part of the European VLBI network. Some of them, one is in Africa, and some of them are in Asia, in Korea, and there are a few in Russia. Due to the war, they have discontinued their participation in the EVN. And this is Japanese VLBI network called the Vera telescopes. And that's the ALMA telescope in Chile. As I mentioned before, that was my first job after PhD. And I got to visit the site. It's 5,200 above sea level. I took off my oxygen, posed for a picture, forgot that I had a screwdriver in my hand before that, which happens to you when you don't take in oxygen. And this is a VLA in New Mexico State. It's an array of telescope arranged in Y configuration with rails on it. And I love this instrument. I've also worked on this site quite a few times. Okay, I can't show you all the telescopes in the world, but I can tell you there are numerous fantastic telescopes. I did not show the SALT telescope. I didn't show many. If I do that, I will take all my time. But the fact that they all are in different forms, shape, and observe at different frequencies bring various levels of technicalities to it. And for every instrument you want to use and every setup you select to use in one instrument, you must justify your choice. So you don't just go, yes, I want to observe Orion KL or Orion Nebula, and I want to use SALT. And the reason is because Orion is beautiful, and I think SALT is a good instrument for observing that. You think that's already a failure for the, well, you think, but you didn't justify it. Okay. Cool. Before I go to the different components of a telescope, I want to go off this screen and show you some technical things. Remember, I said some of the things I said in grant writing applies in proposal writing, except that things get more complicated and more technical. This is the last call for proposal for MeerKAT observation. Okay. And in this call for proposal, the deadline, it was issued on the 1st of June, and the deadline was 15th of July, 2024. And you can see a time that starts to count. Okay. Cool. And here, you're provided a huge amount of documentation. Some of them, if you're not a radio astronomer, you will need someone to explain to you. For example, the bands and receivers. You want to observe, you have these three choices. You can either do UHF band, which covers this frequency, L band, which covers this frequency, S band, which covers this frequency. So for each of your selection, you must justify it in your science. And you can see that for S band, there are conditions, like it can give you up to 100 hours, including overhead. So if you write a proposal that you want to use S band and you're asking for 200 hours, you're just telling them, please reject my proposal. Okay. And of course, people write proposal, as I said, without reading all this information. Okay. These are completely necessary. Here is another technicality. Correlator modes. MeerKAT is an interferometer. An interferometer simply collects signal with each individual antennas, remove the delay in arrival time, and combine the data. But the way you combine the data and the setup of the correlator is this huge computing facility that does this correlation or combines the data. You can do that in multiple ways. You can do that in what MeerKAT considers to be 4K mode, where you combine the data and you channelize all the frequency, all the bandwidth into 4096 channels. You take, it's roughly, if you're observing in L band, you will have about a bandwidth of 856 megahertz. So you take 856 megahertz, you divide it into 4096 places. So one channel will be equivalent to 856 megahertz divided by 4096 in terms of megahertz of each channel. Now, this doesn't give you a lot of spectral resolution. Spectral resolution just means one channel has very narrow bandwidth, okay, in kilohertz or in hertz. You can decide to do the same, but do it in 32K mode, where you divide the 856 by 32,768 channels. If you want even higher spectral resolution, you do this the same thing as above, but you select only 107 megahertz. So we call this in MeerKAT the zoom mode. The reason I am putting out these technicalities, I know is sounding Greek to you, is because you can have all the beautiful ideas, but if you don't understand the technicalities of the instrument, you may not know which one is right for the kind of science you want to do or the kind of observation you want to do. If you want to do pulsars, do you want to beamform? Do you want to search for fast radio bursts? All these will determine what your request should be. Okay. This document is huge, and you will need to take the pain to read it to properly understand it. It includes information about how you select calibrators that you use when you do narrowband spectral line mode, how do you choose your calibrators? And the calibrators will change depending on the band or the receiver you choose. Okay, if you choose S-band, you will have different sets of calibration. If you are interested in studying magnetic field, in which case you have to request polarization calibration, there are specific calibrators for polarization. There are calibration for fluxes and bandpass. These are all technical things you need to understand, and it's a lot of reading, okay? It's not only in radio that is that complex. I will show you another one. This is a cycle 4 call for proposal for James Webb Space Telescope. Everything here is a link that you will need to click to understand the different kinds of observation. You can just do photometry where you just take pictures. You can also do spectroscopy because JWST can do spectroscopy as well. And again, you have to note the time during which this observation will be executed. So all the cycle 4 proposals will wait until July 1, they will start to observe it, and by next year, June 30th, it should have been completed. Okay, but the call goes out. Last year, people submitted. I think those who were approved already received feedback. On the technical terms, this is the instrument. They have different cameras and different infrared imagers and slit spectrographs and near-infrared spectrograph. You have to read the technical things about these things and select which one suits your science. And none of them is a 1-second read, okay? They provide you all the information you need. If you're not careful, if you don't understand it, please ask people who know it to explain it to you. Do not say because you're not an infrared astronomer, you should not write proposal for infrared instruments. No, you can, but it would just require that additional work to be done for you to understand what does this plot mean, what is line sensitivity, what is flux density, ask every question you need to ask, consult an expert, they will explain to you. They are very kind to provide you tools that you will need. There are also tutorials that you can do. Let me find them. I know there are tutorials. Okay, so if you want to know how much time you need to do your instrument, you can understand it here. Tools interface here. Proposal planning video tutorials. So there are quite a number of videos you can find here. You download the videos, look at it. The APT is the interface where you submit the proposal from. So people want to see how it is done, how you select it. And they give you the duration of it. They're not long videos. They know astronomers are impatient people and don't like long videos. So they're extremely short, give you the key things you need, and then you watch the video, you go back. So there are resources, but trust me, this takes a long time to review all of them and start writing your proposal. So please, if you're going to allow weeks or months for grant proposal, please allow maybe half a year for observing time proposal for instruments that you do not know ab initio. Any questions? Cool. Okay, so now I start with what you will put together. In most proposals, there are two components. There is what we call the scientific justification and the technical justification. Technical justification is where you write all the jargons about the band you selected, the bandwidth you want, the correlator mode you want, the time integration time you want, how long you want the sources to be observed, and so on and so forth. But beside your title, I think the first thing, oh, I skipped it, is the title, okay? The title of your proposal, again, should follow the title policy that we discussed earlier, okay? Should be concise, should be complete, should be catchy, and so on. So remember those and implement it. So I get into abstract. I didn't talk about abstract in the previous one because many grant proposals, especially the ones you submit on the web, may not require you to submit an abstract. Well, some will, but you can write it as a summary of what you plan to do. But in observing proposal, abstract is actually a must. Yeah. So you want to, in your abstract, keep it short. I would say not more than 5 to 10 sentences. And you must capture, in the beginning, you put out a global general statement. You narrow down to specifics. You mention the problem statement indirectly and how you plan to tackle it. Okay, I've underlined one. If you see, it says the last piece in understanding the star formation mechanism triggered by galaxy collisions is elucidating the physical relationship between galaxy collisions and molecular cloud collisions. So what you hear in that sentence is that this is a gap between everything we know about galaxy collision and how it relates to molecular cloud collision. We call it cloud collision. So that puts out your problem statement. And then the next task to connect this phenomena, blah, 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 observation is essential. Okay, so you already said this is why I want to do this observation. Okay. In my opinion, I think reviewers, beside looking at your title, the next thing they go to is your abstract. So your abstract must be presented in such a way that the reviewer can already see the true picture of what you want to do before going in to read the details of it. Okay, so please strive as much as possible to keep your abstract very concise and make a good impression in this. Don't let the reviewer get into the details of your proposal with a bad impression from the abstract. We discussed background and rationale. Everything we talked about in background still applies, but this is most cases called a scientific justification, where you have to put out the background information of what is known, narrow down to specifics, and put in the gaps or research questions or the body of knowledge, that information that we do not have yet that is needed. It's not just saying that we don't know about this. You also need to give the reason why you think that your science case is interesting. It's not just being interesting, also tell us whether it is. I think every instrument or every telescope or observatory like to hear that their telescope is unique for doing this. So if you write, for example, MeerKAT proposal, and you say no other array of telescope can achieve the sensitivity required to produce this result except MeerKAT. Somehow you massage the ego of the receivers and of the observatory, making them think, yeah, if they find this, then we are the only ones who can do it. If for example, you say you want to detect a galaxy at redshift larger than any redshift ever detected, and you show any clear evidence that this can be detected if they just observe for 1,000 hours over 2 years. So every day they do an hour or two a week for you, and over 2 years they might get you the full time, and then you stack the data, you detect the highest redshift emission that we have ever seen, which means you have looked back in time the most than any other instrument. So they will be excited about that, to say MeerKAT did this, and we were everywhere on CNN, on the news, published in Nature probably. Okay, so when you write, please start from what is known and slowly narrow down to the gaps, which is the unknown. And I showed that earlier in the example. This is what a typical scientific justification look like. I've put a red line, to show what is known. Galaxy collision, which were abundant in the early universe, are crucial for galaxy evolution. Just stopping there, what this means is that there are observational evidence that evolution of galaxies strongly depend on collision of galaxies. We know that, even if you don't believe it, you somehow have heard it before, that there's a galaxy called Andromeda. If you measure the motion of that galaxy, it seems to be approaching to collide with the Milky Way, with our own galaxy, and merge with it. If it does, we don't know what the fate of the sun and the solar system will be, but it looks like that collision is imminent in I don't know how many billion years to come. We know galaxies collide because there are evidence of ongoing collisions. The example is what you see in this image. The figure on the left panel is the infrared image of the, yes, I think it's infrared. Optical image of the Antennae galaxy taken from Hubble. We know that that shape that looks like an antenna is actually two galaxies that are merging. It is NGC 4038 and NGC 4039 colliding and merging into two. And the collision spot seems to show evidence that there is enhanced star formation due to collision, and that is what needs to be investigated. Okay, how this relates to the collision of the galaxy, whether the increased star formation is as a result of collision of different clouds from the different galaxies as they collide to merge. But this is a beautiful scenario because you can see the unusual shape of this galaxy. It looks like, as I said, antenna. Actually, if you flip it the other side, it looks like map of Africa. If you can turn it around the other way. So yeah, so in your scientific justification, provide figures if they are helpful to guide the eyes of the referee. At least point to the region where you want to point the telescope. The galaxy is huge. If care is not taking, the beam of your telescope, depending on which one you use, may not even cover the entire galaxy. So you can just observe a specific point or make a full map of the entire galaxy if you tend to cover it using what we call mosaic or on-the-fly mapping. So please use the general to specific style of writing. Start from general things, slowly move down. Remember, this started with galaxy collision, and the next thing is to antennae galaxy. This is one example of colliding galaxy. And the next thing is to clouds, and clouds are small subsets within the galaxy. And then the other things you need to specify. So your structure should move general to specific. Every reviewer is not an expert in galaxy evolution. Yes, in the case of telescope time, the observatory tries as much as possible to match proposal with expertise of the reviewers. But however, we all know that in astronomy, people specialize in very tiny specific things. Okay, you come in star formation, there are people who are just experts in masers. You talk about anything else like molecular line in star forming regions, they have no idea, it's just masers. Those can be selected because masers are found in star forming region, therefore they may not fully understand, for example, millimeter line emission and what they trace. So don't think because this is a telescope time proposal, the reviewer would fully understand what you're trying to say. Okay, explain it. Don't make assumptions. That could lead to proposals being rejected. I've put in SJ here. If Zolile is here, he might know why I put in SJ. So the story about the aim of a proposal stays the same. Please don't mix up aims and objectives. I like people numbering these parts, okay? Because if you number it, even the reviewers can say, okay, they have one overarching aim, but they have 6 objectives, and it becomes easier, especially when you separate it. If you model all these things together, they may try to summarize everything to what your aim is, and they may miss the point. So I'll say keep it separate. I'll bring back this example. The aim is very clear. Objective 1, they want to see observational characteristics of collision. They want to estimate the physical properties of related to collision, like size, velocity, velocity dispersion, collision timescale, kinetic energy, and column densities. Of course, if you take it for colliding region, you can also combine it with a region that is not colliding. Okay, so this is an objective. Of course, you can decide to call it science goal. It's objective. Okay. Then the next is to compare with the CO gas. This proposal strength is that the investigators, those who submitted the proposal, already have data from ALMA telescope, like the carbon monoxide emission is from ALMA. They also have an X-ray telescope, and they said, because we already have this data, if we get H1 gas data from Meerkat, if you approve our proposal, we'll be able to take the data and compare it with the CO and verify whether the H1 gas collision and the CO collision are very related events. So there's already evidence of collision in carbon monoxide, which the data is available. If we verify it with H1, then we can see whether these collisions are actually the same, happening at the same spot, or they are independent collisions or events. Cool. And also you can check if there is evidence that hydrogen atom is actually colliding with carbon monoxide. That can also be tested with the results. You can compare with the X-ray data, compare the column densities, compare the energy of the diffuse X-ray emission. And these are all science goals that will help you elucidate mechanism of molecular cloud formation, whether it is linked to star formation and the heating processes of diffuse X-rays, which is cool. So the strength of this is the synergy between centimeter observation proposed for Meerkat and millimeter observation already taken with ALMA and X-ray observation already taken with Chandra. Observatories love this a lot. If you bring idea of doing something that combines multiple wavelengths and produces a result that is very holistic, observatories like to have their name in it, because if a nature level result is produced from this, Alma would do a press release, Chandra would do a press release, Meerkat would do a press release. So all the communities using this instrument will hear about your instruments just because you collaborated, or the PIs use data from the various observatories. Any questions so far? Cool. So silence is golden. So here is the difficult part. This is the part I call the first one SJ, we call this part TJ. The technical justification is where you specify the observation that you're requesting. For example, what is the target? Which source do you want to observe? Okay. This is useful. Think about the Earth. Okay, it's round, right? If you cut it into half through the equator, you have the northern hemisphere of the Earth and the southern hemisphere. Now, depending on where you put your telescope in these two halves, that will determine the patch of the sky you will see. So there are sources in the northern hemisphere visible to telescopes in the northern hemisphere that are not visible to telescopes in the southern hemisphere. Meerkat cannot observe any source at declination plus 50. I think even from plus 30 and above, it's not visible from Meerkat, okay, because Meerkat is in the south. Telescopes in the US cannot see sources at minus 30 declination. So it makes no sense that you have this beautiful science to do, and then you choose a target that you want to observe, and the target is not visible from the telescope you are proposing to. So you have to choose your target carefully. The first question is, can the telescope see the target? If it can, and you are proposing for optical observation, then what time of the year will it be possible to do my observation? Okay. So you don't want to observe an event that you calculate will happen in April. And in April, you want to observe from SALT telescope in South Africa, but your source during April will come out in the daytime. SALT only observes at night. It's an optical telescope. So if you can't make that kind of technical justification. So there is a lot that goes into writing proposal, which is why I tell you it's a huge currency for astronomers. Also, how many hours do you need for the observation? This is not just something you guess. If you want to observe neutral hydrogen, which is a spectral line emission from a distant galaxy, and you know that it is faint, how many hours do you think you will observe to detect that? You need to use data to show from a sensitivity. The observatories provide what they call sensitivity calculator. You check the sensitivity you will get is just what you call root mean square noise level. You compare the noise level to the peak flux of the line you want to measure. If you don't get up to 3 times the noise level, you will not detect the line. At the minimum, you need to detect it at 3 sigma. So you have to integrate longer and longer to suppress the noise, lower and lower, and therefore you can detect the emission. So you do all these calculations, you extract how many hours you will need. I have written here, including overhead. I showed you something on Meerkat call for proposal. You don't just observe your target. You observe flux calibrator, phase calibrator, we call it gain calibrator, bandpass calibrator. If you want to do polarization calibrator. So all these you will include in your observing. Those are just distant objects used for calibrating your data. So in that case, the observation to all those calibrator sources are considered as overhead, and you must add it to the total integration time on your targets to get the final time you will need. And this can be a pain to calculate. It's not easy, and that's why you can't do it last minute. I'm not sure if my PhD student Anna is online, but she can tell you vividly that she's working on a proposal. Her opinion when she started writing it and the opinion now is no longer the same. So the moment you start writing, you start finding the technicalities, a lot of things start to change for you. Okay.
Yeah. Yes, I am online and I can confirm that.
Okay, cool, Anna. Good to hear your voice. So the next thing is whether the requested time is reasonable. I showed that for the case of the S-band on the Meerkat telescope. You've been told we can give you time, but up to 100. Observatories can be tricky. They may not say a maximum of 100. They just said up to 100. Please take that as the upper limit. If I were you, I would not ask for more than 50 hours. If the observation requires more than 50, I will be a bit wary that you may not get the time. I have put an example of what could constitute an unreasonable request. You go to an observatory that gets total free time to observe is 1,200 hours, and you ask them for 2,000 hours to detect a very high redshift galaxy. Interesting. If it's detected, it will be very big in the breaking news, but it means the observatory will do nothing else but observe your source. And that is high risk. Remember, they need to produce research results. They need to have a lot of publication done with the instrument for their government or whoever is funding them to continue to give them money to run the telescope. So merely telling them 2,000 hours, they do nothing else. In 1 year, they cannot finish observation. So they probably can't show any result. And then in the next year, they continue and maybe complete the observation. And then you process the data, stack all the data, and you don't detect anything. Then they are in serious trouble. Okay, so that they spent so much time and detected nothing. Cool. So feasibility of the observation, please check. I'll give you an example of a proposal that is excellent, but not feasible. The observation wants Meerkat to observe the target at night so that they can do simultaneous observation with optical telescope. Okay? And it turns out that throughout the period that Meerkat will execute proposals approved for that year, that the source will be a daytime source. So while the person has given this technical requirement that they need the observation done at night, so that there will be optical telescope observing simultaneously during the night when Meerkat observes the source. It turns out the source is a daytime source. So if that is a requirement that if not executed, the project will fail, then the project should not be executed because it cannot be. Sensitivity requirements, I have explained. Okay, cool. The last thing is that you must comply with the call and the available instruments. Let me go back and use this again to explain that. Okay, I don't know if I can pull up. I can't, maybe. Maybe they've taken it out. For each year, Meerkat has put out a call for proposal. They specify instruments that are available. Okay. Actually, in the first call for proposal, I think it cycles, I don't know what they called it then, but it was just 4 years ago, I think. Yeah, in the first call for proposal in 2019, I think, there was only L-band. Let me show. At that time, only this was available. In the second year of the call for proposal, the UHF was available, but on one condition. They called it shared risk condition. So it means you can write a proposal to do UHF observation, but the risk that your proposal may not be approved is 50% your responsibility. The rest of the 50% is the observatories. So there is a chance they will not execute it. Okay? So they offered this in shared risk mode. Okay. Now, I think it was last year that they offered S-band in shared risk mode. The S-band is a contribution by Max Planck Institute. So this is, you build a Meerkat telescope, another institute, Max Planck is in Germany. They say, okay, you have 64 dishes. We can build 64 receivers in this frequency range, which is beyond what you have. Okay, which is called the S-band. And we will install it on the dishes and we'll build it with our money, which will cost millions of euros. We'll put it in your dishes. And then as a return, you map the entire Milky Way for us. And then you can also open some of the time to make it available to others who want to use it for specific science. So that's how this came about. So if you write a grant proposal and secure, say, 10 million euros, you can go and put a C-band receiver on Meerkat, or you put a multi-frequency receiver on Meerkat, and then you ask them to do your science. Okay, cool. But those technicalities you must comply to whatever they have stated here. You cannot, people have stated, okay, the correlator we have these 3 modes, and then you write a proposal, you say you want a correlator mode of 28,000 channels. While 28 is doable, the observatory will not oblige because it requires significant manpower and a significant time to develop new correlator mode. Yeah. So they'll just throw away the proposal. And subarraying is that you may want to request, let's say you don't need the whole 64, you want the array of 64 dishes splitted into probably 8 places, and then each one of them observe different targets and so on. You can do multiple things, but please be sure it complies with this. There is information on non-compliant. Some capabilities that prospective Meerkat users may be familiar with from other telescopes may not currently be available on Meerkat. This is useful because astronomers tend to write. I showed you many telescopes that I have gotten proposal accepted on, and each of these are different in their technicalities. So you're so used to this one that you use very often, and you want to ask Meerkat to do the same. For example, here, if you ask them to turn on the noise diode and turn it off and supply you with the noise diode data, they cannot do it from Meerkat. If you ask them to observe the sun is so hot that if you point the Meerkat directly at the sun, the heat will fry the entire receiver system, the electronics of the receivers. So I actually was part of the team that did the first Meerkat solar observation, and the closest we could go to the sun was 2.5 degrees away from the sun. We've done that twice. We did one of the observation when the Parker Space Probe was going close to the sun, and we did the last one just December 24th and 29th. The observation was done again. Okay, cool. So there are lots of things. If the tiresome thing is you read equivalent of 100 times a proposal before you can understand the system, but please feel free to ask questions, and the observatory will always respond. Any questions? None.
Yeah. A short question, please.
Yes.
So, in some of these calls for proposal, will the telescope management, they specify the type of observations that can be made or that can one can write on, or is it just a free writing where you just whatever comes to your mind, you observe, you begin to write? Or do they restrict you to the kind of things you will observe, or kind of?
So they restrict you only to the instruments you can use, but they don't restrict you in terms of the science. The science is up to you. Okay. For example, the instruments provided in this call for proposal can observe continuum and can also observe spectral line, like neutral hydrogen. So they don't tell you you must write proposal that to detect neutral hydrogen in a galaxy. No. That is your decision. Your scientific justification is your decision, but your scientific justification must align with the instrument they have available. Okay? You don't go to them and say, oh, I want to observe CO molecule, which is only observable at 115 gigahertz. But meanwhile, the receivers they told you they have available are these. So your CO is, yeah, it's already cut off from the receiver band. So anything you want to write, let me try this. I can go into Meerkat and show you successful proposals. I'm getting old. Okay, so these are examples of successful proposals. This one says probing the turbulence region of solar wind at L band, and there is also at UHF band. This is follow up on localized FRB. You follow up localized FRB fast radio burst. This is a DDT. DDT means director's discretion time. These are operators. These are observatory data. This one said Crasco and VAST radio transient follow-up. These are transients. I'm trying to find something else that is not. Whatever you see this phase up is observatory doing it. They use it to, they just monitor their bandpass calibrators. Those lists they give you, their calibrators they've been monitoring. This is a supernova remnant that has been observed. So different signs. Another FRB, sorry, I've been doing this FRB. Diffuse emission south of this target and night observation. I can tell just from the title that these guys insisted on night observation so they can follow up with an optical telescope the same night that the observation is executed. So this is a pulsar, following up on a pulsar observation. This is observing a filament. So you can propose whatever you like, but you can propose what the telescope cannot detect or observe. This is gamma ray burst observed, right? So there are lots, and yeah, you're welcome to submit any proposal. I wouldn't show you the proposals that I have reviewed, but it has yeah, a wide range of submissions. Did I answer you, Chifodo?
Yes, thank you.
Cool. So compliance is a must to the call. Nobody restricts your hands as to the kind of science you do, but your hands are tied by the available equipment and available total number of time. The observatory will always tell you in the call how many hours they have available. In the case of Meerkat, it ranges between 1,300 to about 1,700 hours in the whole year. Don't ask for too much. Typically, they receive hundreds. Last year, they received 193 applications, and the oversubscription rate, the number of approved proposals were probably about between 50 and 60. So I remember the oversubscription rate is around 3. So for every 3 proposals that gets to Meerkat, only 1 is selected. That is also useful information because it tells you how competitive this is. Meerkat is, well, it was a bit competitive in the beginning. Things slowed down a bit, but ALMA had a oversubscription rate of 20. So for every 20 proposals, there's 1 acceptance. So you make sure you write a top quality proposal if you really want time on the telescope. Okay, let me get into a bit of details. Please, this will be slightly technical as I mentioned, but feel free to ask questions. Here, we propose H1 observation of Antennae galaxy. H1 is neutral hydrogen. You observe it at a specific frequency of 1.42 blah, blah, blah gigahertz. So it means that this observation can only be done at L band. Okay, you remember I showed you the UHF band, L band, and S band. L band is the only one that covers it. Because you're interested in spectral line, you want your channel width to be very narrow. So in this case, this group have selected L band 32K narrow band. This is the one I told you is called the zoom mode. So instead of using the full 856 megahertz bandwidth, you zoom into the area you're interested and take 107 megahertz around that area and then channelize 107 into 32,000. Remember, 32,000 is just the approximate. I gave you the full numbers. So that gives you that each channel becomes very narrow and, of course, narrow in frequency, which you can convert to velocity. and one channel becomes 0.7 kilometers per second, which is now good for you to start seeing velocity kinematics of the gas in the region. The other information you find here is the beam size. So remember, Meerkat has long baselines, but it also has short baselines. So if you want the highest resolution, you use the longest baseline, which has a separation of about 8 kilometers. That's the most separated two antennas, has about 8 kilometers, and that gives you around between 6 and 7.5 arc seconds, depending on the weighting parameter you use. Okay, so if you use natural weighting, your sensitivity or noise level will be 0.428 millijansky per beam if you observe for 12.5 hours. So all this you can get from what we call, let me see if I find it. It's not just reading, you also have to try out things. So if you come back here and search sensitivity, okay, so Meerkat has a sensitivity calculator that you can use. Why is my network slow? They explain how you use it, how the calculations are done. Let me slow down. So first, this is explanation of the sensitivity calculator. You can find it here. I'm going to open it and show you. And then the bands, if you put how many minutes you want, and then it shows you what they use robust value minus 0.5. It tells you what sensitivity you get in microjansky per beam. So if you click on the sensitivity calculator, yes, you can check the data volume. So if you're using 64 antennas, the full array, and you want to do only 2 polarizations, let's say you're not interested in magnetic field, and you want data autocorrelation. Autocorrelation is like single dish data. Beside taking data from one telescope and combining it with the other one, which is cross correlation, if you want the autocorrelation as well, you can say yes. I'll show you the difference between yes and no. If you are observing for 20 hours and you have a dump rate of 8 seconds, so every 8 seconds, one data point is dropped, and you're using 4K channel, and you say, tell me how much data. Your raw data will be 2.4 terabytes. I can bet all your laptops are within 250 gigabyte and 500 gig. At most, if you have more money, you put 1 terabyte. So it means the data we will acquire will not even fit into your computer, the storage, how much more processing it. And that's 4K channel, 4,000, only fewer channel. Now let me change this to 32,000 channel. You have 19.5 terabytes. Okay, so your problem multiplies. Now you say, oh, I'm interested in high time resolution. I want to see if something varies every 10 seconds. So you go for 2 seconds dump rate. You have 77 terabytes. That's for, so this is where many people run into trouble. You are fantastic in writing scientific justification, but when you ask an observatory to give you this level of data, they produce it, you leave it in their archive, and you don't know how you will download it. You're not unable to go get your data, do the science you promise you will do. Okay, now remember, this is just 20 hours. It's not a lot of time. Let's say you decide to request for autocorrelation, both the cross-correlated and single-dish data, you want both. You have 80 terabytes. Now, let's say you want to do polarization, you ask for the full pole, that is vertical, well, we call it XX, YY, and you also want XY and YX. That's a 4 polarization. You are at 160 terabytes. So these technicalities are extremely useful so that you know that you need to justify to the observatory that you truly can handle these data when they produce it. Okay. Okay, I hope that is understood. Now the sensitivity calculator is right here. You tell them the band, okay? Let's say we use UHF band, the channel, let's use 4K, the bandwidth you want 856. I can use 500. The declination at which you want to remember, if you're observing lower declination, no. If you're observing higher declination in plus values, then the telescope is pointing towards the Earth, okay? So the path length is longer and your noise level is higher. So I'm going to use -50. The redshift frequency, I can use 670 megahertz is fine. Integration time in hours, I'll use 20 again. And you calculate. No, out of range, 300. They can only do 300 here. So I'll use 200. So it means if I do this observation, my source is at this declination, my noise level will be this value, okay? If I use natural weighting, that is robust parameter around 0, then my noise level will be this, okay? The column density of H1 that I can measure will be these values. The TC system noise temperature is 24.9 Kelvin. Velocity width, so each of my channel will be 35.3 kilometers per second. The beam correction factor will be 3. This is because I have chosen beam width because I've chosen this channel, because I can actually choose a narrower channel. This is 4K. If I choose 32K, you can see my velocity resolution has improved to 4 kilometers per second. Does that make sense?
Yeah.
This is technical, yeah. I understand. But that's why if you know the science and you don't understand the technical details, then you need to either invite somebody who have the technical skills to your project to be the technical coordinator to tell you, yeah, this thing you want to do is fantastic, but Meerkat cannot do it. Or Meerkat can do it, but you have so much data you cannot handle it. So somebody needs to inform you. Okay, I'm slowly running out of time. I want to show you lots of things, but please feel free, go in, play with these things. Mosaic. To mosaic means you want to cover this area, but the beam is just this size. So you need to add many, many beams to cover this, okay? And so on. You can also check your UV beam. So play with these things. If you want to submit Meerkat proposal this year, it's just in June. Start now to read this. A lot of this will not change. They will issue out a new call, but a lot of this information already existing will stay the same. Okay. Any questions? I know that I'm running out of time before you say discussion time. Cool. So I've shown you some of these technicalities. This is how you determine how many hours you need because you know the noise level you want to achieve. You have an idea of the peak of the source. So with this sensitivity, you can see where it is indicated that the lowest sigma will be around 10 times the noise level to detect the source, or even higher, depending on the performance. Okay, you choose your flux scale if you want to. If you don't fix it, the observatory will provide you one that is available. And then you've given your description of your observation and the technical justification. But this is not easy to write because it needs all those things I played with before you can come up with this simple one paragraph thing. Proof of team capability. I mentioned this in grant proposal writing. My mouth is drying up, excuse me. If you get all that data from 12.5-hour observation, what are you going to do with it? How are you going to manage the data? Well, how will you calibrate? Where will you calibrate? So we've indicated, for example, in this proposal that we have access to, we will use Caracal and Oxcat. Caracal to do spectral line, Oxcat to do continuum. And we have access to 25 terabytes on ILIFU, 250 terabytes on NW cluster, and 10 terabytes in ADC, which is at the National Astronomical Observatory of Japan. So in total, we have access to close to 300 terabytes, close to that, which is good. We'll transfer the data over the internet. That is horrible because I've tried it before. It's just never happening that easily. So what I've done in the past is to take by hard drive, send it to Cape Town, they plug it at the back of the archive computer and directly copy the data and courier the drive back to me, and I courier it to Japan. You mentioned your team. We have a PI. Now you can see the names of the people involved. Tugay was the PI of the proposal. I led and coordinated the technical side of things. So I was the technical lead, coordinating both things that has to do with data reduction, overlapping with Meerkat, and making sure that calibration is done properly, and blah, 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 and post calibration imaging and so on, done by someone else. Okay, so you can see how you describe your team. In this team, because many observatories do double-blind review. Double-blind review means the proposal is reviewed after the observatory have removed the names of the authors of the proposal. So this segment is not sent to the scientific reviewers. And then you are requested to write a proposal in such a way as not to make reference to who you are. Don't say our team, or use references to papers you've written, so that don't make it easy to guess that this is the author of this proposal. If you do, the observatory reviews the proposal first to make sure it's double-blind proof, and then they remove the title, the names of the authors, and then they present them to the reviewers. So the reviewers are reviewing without knowing who you are. This is a system that was developed by the US when they had problem of bias in reviews. When people see big names, they are more disposed to accept. And there was also issues about gender bias and so on and so forth. So most observatories are going towards double-blind. But in any case, the observatory needs to see that your team, while that doesn't go to the scientific reviewers, that your team is capable of producing result, and you can see the justification. And now that I've shown you the last part of this proposal, I can tell you that this proposal was accepted and the observation has been done. The data is not processed yet. If you want to get your hands dirty, you can contact me. I'll let you play with it. Okay, let me spend another 5 to 10 minutes. Useful tips. Reviewers have many applications to score, make their life easy again. Like I said before, all these are just repetition of what I said before. I'll show you the new things soon. Okay. Be clear, precise, avoid complicated languages, use appropriate formatting, do your proofread and grammar or spell checks. Stick to the proposal length. I didn't show you that, but it's there in Meerkat. Prove that you are capable of delivering, not when you get the data, you suddenly grow cold feet and it's too late. If actually Meerkat has a segment where they ask you whether you've done proposals before. If you're submitting a proposal, and if you say yes, they just tend to go check whether you've published the paper. Actually, every few months, the chief scientists of the observatory write everybody who have gotten a time to ask them which paper has been published from that data. If even after you've published, he asks you again whether was there any other paper that came out of this, and you'd keep getting that email every January and June. You don't need to include big names. It doesn't mean that if you're working with a big name, you shouldn't, but it's not necessary. Actually, with the double blind, we won't even know because their institutes and their names will not be shown to the reviewers. Don't forget to do proper referencing. That's useful because sometimes the referees tend to go look at what you have referenced to see if they can obtain some additional information that is helpful for them to make decision. Verify your technical justification. You can see how complex it can be. I have a proposal that was ranked very high. The one I screenshotted and put in that scored 7. 7 out of 10 is super high for Meerkat, but the proposal was still rejected because the reviewers misunderstood something in the technical justification about the spectral resolution chosen. There was some ambiguity in what he stated, so that cost that good proposal telescope time. Do not be shy to ask questions. I was part of commissioning of Meerkat. I still ask people questions about certain things. Things change in the system, even the things that have been there already, you don't know whether they can be flexible enough to do certain type of things that you want to do. I'm using only Meerkat here because, well, if I use the other one, I need to also explain the technicalities, and that would take time. So the telescope is free. The people who paid money to build it open a small fraction of the time to all astronomers around the globe. Take up the challenge, apply for time, observe your target of interest, but please be careful to present a strong case, so that you can get telescope time. Remember the policy that to write a proposal is not a joke, okay? Plan well, allow yourself sufficient time, prepare, ask questions, discuss with your friends and colleagues, put it together, give yourself sufficient time so that you don't go in last minute panicking, or you send it to someone and you suddenly feel that person has nothing else to do but to read your proposal and send you feedback. Remember that the person you would want to give you feedback also might have something urgent in his hands to do that have higher priorities than your proposal. And that could cause you additional delay. And by the time you receive comment from the person, you have no time to implement it, and you submit something that probably you did not check properly. Yeah, that said, I received too many applications for MSc and PhDs. I think so far in 2 years, I've received well over 100 applications for people who want to do this. If you're ever dreaming of coming to do PhD in my group, get ready. You're going to write a proposal. That's one of my requirements. I do want students to get their own telescope time. There is a joy in doing that. Remember, when you write and you're successful, that data for 1 year is exclusively accessible to you and only you. Nobody else can see it. The data I showed you on the Meerkat archive, if you create an account, you can log into this archive. Where is it? There. You can log in there, but you would never be able to see these two data sets, this one and this one. Okay, because the observation was only done on the 29th of December and 24th of December. So it's still in proprietary. I can access it. I can view the details of this observation, but you can't. You wouldn't be able to see this. Okay, so that's the privilege of having proprietary data. I'm not the PI of this project. I'm just the technical lead, so I have access to it. Just to mention, the one I'm PI in is still down the line. So you get the data, it's yours, and it's yours for some time. After 1 year, they'll hope you've published it, and they make it open to the public. Okay, anyone else can now access it. So yeah, there's the joy of having that proprietary time and the joy of putting in your CV that you have written a proposal that experts reviewed and considered it worthy of being observed with a telescope. So for me, well, Anna just commented she's writing a proposal to do salt spectroscopic observation. And if she's successful, I'll get a glass of wine and then she can get the work done. So I'll say take the challenge, try a proposal. This is my own homework. For African students, there is a dedicated time for African researchers on this telescope. This is a huge, read about it online. There are technicalities. I don't know all the details. I have, but I have contacts at this observatory. I sit in the time allocation committee of sort. I will see your proposal, but if I know your name, it doesn't matter because we have to, the time allocation has to justify that the science makes a lot of sense and to some extent is doable with the telescope. But I'll say, because there is a chunk of time that they're willing to give to Africa, in most cases, they are not good enough proposals to use up all the time. So why not take up the challenge to do a good proposal to get time on very professional large telescope on the continent? And then I'll stop there and we do discussions. Thank you.
Yeah, thank you so much, Professor James, for the marathon lecture and demonstration you have given to us. So I think it's time for general discussion now. So, of course, in the program, we have 30 minutes for general discussion, and we are expected to end the program by 3. But we don't need to exhaust all the time. Once we discuss satisfactorily, we can end. So this time around, if you have anything concerning all the lecture you have received since the thing started, this is the time for discussion and interaction with the professor in the house that is giving us the lecture. So thank you once again, Professor James, and be ready to answer our questions.
Thank you.
Thank you.
I guess the floor is open. So.
Yeah, the floor is open for whoever that has anything to say, questions to ask, or some other comments to make as regards our program.
Wow. Okay. Julius.
Yeah, I can see a hand up. Julius. Julius, make your comment or your question.
Julius, you're muted. Julius?
Okay, yeah, thank you. So is it a good thing for you to get time on a telescope before applying to opportunities, or is it better to wait out and get the opportunities before you apply for the time?
What does opportunities mean? Julius? Julius, what do you mean by opportunities? You're muted.
I'm thinking of maybe, for example, you are planning to apply to a PhD opportunity or postdoc or whatsoever. Like in preparation to what you're about to face, is it best you apply for the time or you hold on till your supervisor tells you, okay, apply for the time?
If you know what to do with the telescope, you don't need to wait for any opportunity to apply to use the telescope. The observatory puts out a call, most cases once a year, for some twice a year. Okay. So if you wait and you get to get a PhD opportunity and you get the PhD opportunity and the next call, you got the PhD opportunity in January and the call closed in December, the next call is in December. If that is the instrument you want to use, you have to wait 1 year into your PhD to apply for time. So what is important is not whether you have opportunity or you're planning to apply for an opportunity or not. What is important is that you have a scientific idea that requires an observation to be done. And that you can do at any given time, whether you have a PhD position or you're just doing a research assistantship with a professor, or you are MSc student, or you're not even doing anything, but you're an astronomer who understands how to do research in astronomy. So you can apply for time anytime. Isaac?
Okay, thank you.
Okay, Isaac. Isaac?
You're muted. I guess some of them are talking without knowing that their mics are muted. Isaac, can you hear me?
Isaac, unmute yourself.
And
Hello?
yeah, hello.
Sorry,
Yeah,
I
we
was
can hear
asking,
you.
yes, are there any sites that one can use to learn on how to use the telescopes in any way that you want to learn?
Every telescope provides sites where you can learn about them, and they provide videos or lectures, and they provide technical people who are available with their emails to respond to specific questions. So there is no site you will go to and it has information about all the telescopes, but you pick a telescope that can observe your targets at the frequency you want or wavelength you want, and then you go to their website and read about it. They usually will provide documents like the way Meerkat has provided. Some of the documents are very daunting to read, but yeah, you want a free time, you have to read it and understand it.
All right.
More questions?
Yes, Edidius.
Yeah, Eddie.
Eddie, unmute yourself and talk.
Yes, Prof. I'm trying to find out on the technical aspect when giving out the report, because I've seen when you are also presenting, you talked about technical aspect, and in other articles that probably have gone through, we see the same technical aspect that the astronomers use when giving out report. What I mean on this ground is that the use of mainly frequency, because I've seen and I've noticed that when giving out reports, astronomers, they prefer using most frequencies and they rule out the wavelengths. Why is it that astronomers like using most frequencies on the other hand, they can also use wavelengths to describe in their reports?
James, you are muted. Prof. James, please unmute yourself. Yeah.
Yeah,
Good.
so although I think you've changed the setting that people cannot unmute by themselves. So that's why I was struggling to unmute myself until you requested it on the system.
Okay.
Okay, so for each person that raised hand, you need to go as the admin and ask the person to unmute. That's the only time it allows the person. I tried to unmute myself again, I couldn't. Okay.
Okay.
That said, Edidios, astronomers are very strange people. They choose to use whatever they like to use. There are people who would start writing proposals, they use wavelengths. I think if you ask me to say, I would say that the bias in radio is that people prefer to use frequencies. Because when you say 1.3 centimeter image, people start in their head reconverting to frequency to know what frequency band you're referring to. So in optical, people tend to not use frequency because it's too high a frequency. They prefer to use wavelengths. It's also too short, so they use Armstrongs, okay, which is a unit of length in meters. So this is just biases of astronomers. The first group of people start using certain things, then it almost becomes a convention. In some cases, it's even a conflict. The bands, the way I showed you, we use band 1, 2, 3. We use K, Q, U, S, L, X, and so on as astronomers. The engineers don't like that. The engineers code the bands themselves, and they call it different things. So just the same way we don't like to use power densities in pounds per megahertz, we prefer Kelvin or Janskis. So these are just conventions, and it really doesn't matter too much. Yeah.
Oh, okay, Prof. I was worried.
Don't be. If you like, you write us in wavelengths. If we struggle, we use our calculators, or just write a small Python code to convert it.
Oh, thank you.
Aman?
Yeah, so my question is what is flux in research of telescope? How do you access the SARO calculator? And how can you use the time proposals? Like, for example, someone is researching like quantum fields like Higgs boson or superfluid properties of galaxies. How can that time proposal be translated into like useful fields like in the well, like for example, a single point theory gave us quantum solvents and Meg-Gauss fields in trains. So how do we turn our time proposals into useful practical things in real life? And there's also something happening on April. What's happening on April with the assignment? Yeah.
What's your last question again?
I'm saying you said there's an event happening on April that we have an assignment due on April. Do we pay attention to that or ignore it?
April.
Yes.
I don't remember which.
On the FAST4Future workshop.
Oh, that's not me. I mean, Odo will answer that.
Okay. But back to the previous question.
Yeah. Okay, so your first question is what is flux, right?
Yes.
So flux, we usually say flux density is the power emitted per unit area per bandwidth. Okay, per steradian. Well, when you have a synthesized beam. So it's just the rate at which an astronomical object is releasing radiation. In this case, very faint radiation in radio wave band. Okay. And your second question is, how do you relate this if somebody wants to study, let me use the word, fundamental particles in a galaxy, in a distant galaxy? Well,
and superfluid properties of galaxies as well.
Yeah. So for superfluid properties of a galaxy, you might need the physical properties like densities, kinematics to now fit into a model to extract those information. All you can do with a telescope is to make an image. But from the image, you implement some form of analysis, you extract information of physics. From the extracted physics information, you can do additional physics with some modeling. Okay, so for superfluid, you probably can do that. For detecting fundamental particles, my answer is I don't know. There's no direct detection of these particles. However, if you know of any form of interaction between such particles and hydrogen, okay, and how it can be picked up in observational properties of hydrogen, then you can propose observing hydrogen as a proxy to studying those fundamental particles.
So how do you turn those things into useful products? Like the one which I gave of the quantum solvent, those theories or observations into useful products that can help the world.
What product is useful? Let me...
Like for example, I gave an example like from string theory. There's a single point theory which helped before that to help create string theory. So single point theory gave us quantum solvent and Meg-Gauss.
So, you know, when people use product, they want something tangible. But I can tell you one product of astronomical observation. Do you remember what we call detection of gravitational waves when it was first detected directly?
In 2016, right?
Sorry?
Isn't it 2016?
Yes. So when the LIGO project detected. So you can use astronomical observatory observations to verify existing theory and substantiate them. Now we are almost close to, well, we have imaged the event horizon of a black hole, and we are getting ever closing in on a lot of things about black holes and all the theories. If you're talking something tangible, well, we always proud ourselves as the ones who led everybody to start using Wi-Fi because someone wants to transfer astronomical data and decided, yeah, why don't they just propagate it through the radio waves and send it and collect it on the other end? And this was done, I think, in Westerbork, and we have Wi-Fi. So there are substantial spin-offs, but that's not what astronomers chase. You can see in the example proposals, we are looking for fundamental knowledge of our universe. If anything comes out of it eventually, that's a plus. There are observations looking, the people who did the W map, they've won a Nobel Prize just for looking at the cosmic microwave background, showing that in every observation you do, in the background, there is a 2.7 Kelvin emission that comes from the cosmic microwave background. And this is supported by theory as well. So yeah, it's not every 20-hour observation that will give you big results that will answer a big scientific question, but all of them slowly put together might give you clues.
Yeah, how do you access the SARO calculator that you showed on the screen? How do you get the link?
Let me send it to you.
Okay.
I'll paste all the links that I have here on the chat. Let's see. That's the archive. You can create an account and you'll be able to access all the open data sets. And this is the Sarao. If you actually put Meerkat call for proposal, you'll find all this. No. I have, okay. Control C, that's the calculator.
And the April thing, what is the Professor Odu going to say about that? What's happening on April?
I leave him to that one.
As regards FAST4Future. Hello, Aman.
Yes, sir.
Okay, you mean what we have for the month of April in FAST4Future?
Yes, the assignment. Yes.
Good. In FAST4Future, after this workshop, we usually have our monthly seminars. So we still have a seminar for the month of February. I think probably exactly 2 weeks from today, we will have a seminar. And the monthly seminar continues until when we have another major activity like this workshop, because there's another workshop that may still come probably by May or June. We will have another workshop because in the lifetime of this FAST4Future project, we still have 2 more workshops to host and probably 1 more summer school to host. But outside of that, we continue to have our monthly seminars where researchers, students, professionals come to showcase their activities. So for the month of April, for now, what I'm sure that we will give out will be one of the monthly seminars. Except if things change, I'm not sure whether there will be any major activity in the month of April. But we already have all your contacts. We have already an existing email group which we created after the summer school. So whenever there is any activity that will come on, we will post it to you so that you can become part of it. So even this seminar of the month of February, I think I will still invite you in that group so that you can join and see what our colleagues across the partner institutions are doing in terms of science and research. So for now, after this workshop, we may not have a very big activity until maybe around May or April or June, sorry.
So should I worry about the assignment or ignore it?
Okay, the assignment that we gave after the summer school. Hello?
The assignment you put on April 25th, you open the date April 25th and close the date April 30th. Should I be concerned with that or ignore it?
Well, you ignore it for now because things are changing and things may be updated as we move on. For now, it may not be there, but just be up on the site and see what is going on because, of course, you see that this workshop we're having today wasn't in the original plan, but along the line, the thing came up. So as things go on, we will be updating. And if there is need for any such, we will let you know on the website.
Yeah, please continue to update me on any latest meetings. Thank you for your response and help, professors. I appreciate it.
All right, thank you.
Thank you. Oh, okay. I have questions from Portia Lehodi. How do funders generate benefits from example astronomical projects? National Research Foundation pride themselves as the organization funding most of the research going on in science, for example, astronomy. And whenever there is a new result, they're always among the first to put out a press release. There are two reasons nations fund science. One of them is because they want technological development, and South Africa is a good example of that. I mean, it's the only country that has such a huge astronomy project running into Meerkat, for example, is 4.2 billion rands just to build the 64 dishes, excluding operation cost. So whatever good science that is produced, they take credit for it as the ones paying for it. So one of the big things beside technological development is the national pride that comes with it. Remember when the space race came, people were throwing in millions of dollars at just putting things in space, and whoever does it goes out. You get nothing, your money is gone. But yeah, you've put something in space and then the pride is there. So it's usually technological advancement, human capacity development, and national pride. In scenario where you have multiple sources you want to observe, how do you allocate the observation time? It is up to you. Your multiple sources, if they are equally bright, okay, one is 2 Jansky, the other one is 2 Jansky, you can give them equal amount of time. So if each one will cost you 5 hours on source plus overhead, so it means you need 10 hours to observe the 2 sources. So you can observe, you can give a list of 10 sources you want to observe. Excuse me, and you just mention the observation time. So if you have 2 sources, you put in information of one. If the informations are not the same in terms of brightness or RMS you require for each, then you put one at each time, calculate one you want on this source. It could be that you need 50 hours for 5 sources, but one of the sources, 5 hours is enough. For another one, you need 20 hours. For another one, you need 7 hours. For another one, and that way. Okay, that's how you allocate time. You don't allocate time just on take an average, because the average total time you want may not be enough to detect the emission you want in one of your sources. So the total time you want per source should be a function of the time required to detect the source. Osha, did I answer you? What are the qualifications of writing a proposal for funding? You done well? No. Read the call for proposal. In some cases, you don't need any qualification to apply. In some other cases, you need to have a PhD. There are, for example, the one I showed in the beginning from Royal Society. They have two categories for Africa, and one is called the Rising Star, Africa Rising Star, or something like that. And that one, you need to have had PhD, and your PhD need to have been held for less than, I think, 10 years, they said. And then the Africa one, Royal Society Africa grant, you need to have had at least around above 10, maybe above 15 years of being in research since you got your PhD. So some require PhD, but some grants don't. So just read the call for proposal. Lucy, I'm not sure if I answered you. Those are usually specified. Some don't require any qualification. The call by IAU Office of Astronomy for Development, where they fund small projects like to buy a small telescope and go to remote place and show people night sky. Those ones you don't even need to have a bachelor degree, provided you can show evidence that you can execute the project. You might be able to get funded, and you write a good proposal. So it's all a function of the call. And if there are such conditions as to what qualifications you need to have to apply, it's always stated in the call. Okay. I don't see any more questions on the chat. And I hope I've answered as much as I
think there
could.
is one more question there. Is the researcher responsible for calibration?
Oh, for calibration, or is it done by the observatory? Okay, the researcher is responsible for whatever happens to the data after the data is taken. However, most observatories develop pipelines to calibrate the data and image it to make sure they reach the desired sensitivity that the researcher has requested. But the image they produce, the calibration and image they produce is not optimal. It's just a quick look kind of thing. Okay? So it's not science ready. So it simply comes back to the check, we call it quality assurance. They check that the quality of the data is good, they're able to image it, and they're able to achieve the sensitivity you wanted. And that's all they do. So that image you can collect as a quick look, but it's not ready for publication. Okay, so yeah, so the researcher is responsible. That's your job. Okay. What makes a telescope proposal Nobel Prize worthy? Oh my goodness. Okay, that's a very tough one. I've never won a Nobel Prize. I have no idea what is Nobel Prize worthy. But I've been told by friends and colleagues, including many of them who are recipients of Nobel Prizes, that you don't do research to win Nobel Prize. You do research to find fundamental knowledge, understand what you're trying to do. But if something you find becomes significant enough in the world of science, and the Nobel Prize award committee considers it as worthy enough and gives you the prize, then that's a byproduct of your research. So we don't know what is Nobel Prize worthy. You just do your research, and if it eventually happens to win the award, good for you. If you want, I share pictures of me and many Nobel Prize winners. One of them, Brian, that we spent most of August together drinking wine. Brian said he had no idea he would win Nobel Prize. He's Australian, so he just kept doing his work, and then he got the prize. So nobody knows what will win Nobel Prize. It's even more weird now that Nobel Prize in physics was given to somebody in computer and machine learning last year. So you never know. So maybe tomorrow they will award a physicist Nobel Prize in computer science. I don't know. So
so by a way of explanation, it is not the proposal that earns the Nobel Prize. Rather, it is the result of the research done with the proposer.
Yes.
So it is the research, the result of the research that can actually win a Nobel Prize, not actually the proposer itself.
Exactly. I can also tell you that winning a Nobel Prize is also a function of how careful you are in looking at your data. If tomorrow there is a Nobel Prize in astronomy for discovery of fast radio bursts, a person called Lorimer will win that prize. He discovered it in 2007. However, what he called what became that discovery is just the one he found, he paid attention to. People have looked at the archive data of Parkes telescope in Australia. It's a 62-meter telescope. You know, they were looking for pulsars many years back, even before the FRB was detected. So somebody just used machine learning, went into the archive, searched, used automatic process to search all the pulsar observations and found many other FRBs. So FRB has been sitting in the archive. The person who observed it just never paid attention. So the question is, should it be given to Lorimer for observing that, or should it be given to the person who did the first observation in whose data the FRB has been sitting? What of the other older data that may have FRBs and so on? So
Be given to both.
sorry, they give it to both.
Yeah.
Yeah, you leave it to the panel. We are not the panel. There are other examples. One is of the first Black radio astronomer trained in Cambridge, who happened to be in the same university as me back in the days as Odo as well, Professor Sam Okoye. He was the first to observe Crab Nebula, where pulsars were discovered. But of course, he was looking for something else and never paid attention to the time variability of some fluxes, which eventually Professor Jocelyn Bell did and discovered pulsar. But the Nobel Prize was eventually given to their supervisor, Professor Hewish. So is it who did the observation or who processed and found the thing, or the person who had the idea of the kind of project that should be done? So this becomes fairly subjective and people will have their opinions. And my opinion is keep your eyes off Nobel Prize, do decent science. It might win you one in the future. Somebody said they should be given to the person who made machine learning model. Okay. I don't know. When they give the Nobel Prize, you can go object to whoever they gave it to if it's not the person.
Sorry, Prof. May I come in?
I mean,
yes.
Okay, I mean.
Just to remember about Professor Jansky. He was looking at different things.
And he found radio astronomy.
Sorry?
You mean Carl Jansky, right?
Yes. Yes.
Yes.
The time he did not know that he's going to discover, is it the radio?
Yes, radio waves from the Milky Way,
distance
from
object.
Yeah.
But was he the one who processed that data, or he just discovered?
He was the one who processed data as well.
So he did both discovering and processing the data.
Well, he did the observing. To discover, you have to process the data to discover. So he did the observing, he did the processing of the data. He found that there is this emission he's detecting every 24 hours. And he keeps finding it, and it appears around the same time. So he knew something is definitely, at that time, he was just spying. He was a spy radio frequency engineer. Yeah.
Okay.
So he found that he kept trying to see if anybody was sending something at the same time every day. But he realized, no, this is coming from natural source. And it was eventually proven to be from the Sagittarius A star in our Milky Way. That's the black hole in our Milky Way. Okay, Is there any other question? I need to run in 3 minutes because I have to pick the kids from school, you know.
Okay, Aman.
I've opened the link for the calculator. So how do you like access it? I have your link. I opened it. Where do I click to do the simulation?
There is, let me share screen again and show you if I'm allowed.
Yeah.
Need to take this off. I guess you are here, right?
Yes, sensitivity calculators. I'm on that page.
See this link?
Yes, the app. Yeah.
That's the app. If you click it, it opens this page.
Okay.
And you can, this is sensitivity calculator link. Each of these is a link, data volume link, mosaic, sensitivity, UV beam.
It says I have to log in, so I have to create an account.
Yes. You can see I'm logged in as JC.
Okay.
Yeah. And creating an account is free. So go ahead and do it.
Thank you.
Cool. Any other question? Have 2 more minutes.
Yeah, finally, if I am given a telescope time for observation, do I need to visit the telescope to make the observation, or I just sit at the comfort of my office and wait for my data to come?
Oh, interesting question. Some observatories, if you want to visit, they even provide additional funding for you to travel and visit. But those are mostly single dish telescopes. For interferometers, if you come to South Africa, you're not even allowed to go to the site where Meerkat is. So you don't need to go there. However, you are required to prepare the script. We call it OPT. You prepare what we call scheduling block that you will submit. Let me see if I can find mine and show it. Okay, let me share screen again. So when you eventually are awarded time, they will make you prepare the observation script, and that observation script schedule is what they will use to carry out the observation. Observation planning. Yeah, this is the OPT, observation planning tool. And there is lectures on how you can, and videos and YouTube, you can find it on YouTube. You can log into OPT. I'll show you what it looks like very quickly. So these are, you can see that Antennae Galaxy. I submitted all this. I think it's been executed. I don't know, maybe it hasn't been. But if I open any one of this, you can see what's, so here you have all the information, proposal ID, OPT ID, blah, blah, blah. And you see the mode. This is 856 megahertz on 4K, and this should be zoom mode. This is wrong. Wow, I'm happy I looked at that. This should be 856 zoom mode, but 32K. Okay, I'll check that later. So you get the center frequency around H1 and integrate dump rates. Remember I say how long you want before you dump a time. And if I go into configure, okay, that's how the observation is set up. First, they'll observe a calibrator. Okay. Second, this is delay cal to check for time delay, flux, and bandpass will be done with this source. Second is the gain cal. Next is our target, the Antennae Galaxy, then gain cal, Antennae Galaxy, gain cal, Antennae Galaxy, gain cal, Antennae Galaxy, gain cal. Then we do delay, flux, and bandpass again, gain cal, target, and so on till we stop at gain cal. I can simulate this. I can show you the UV So this is how it will be. This shows you when the source will rise and when it will set. The blue line is our flux and gain curve. The red one, it's our flux, delay curve, and the bandpass. This is our gain curve. This is the target. And this is, I think, another gain curve. Okay, so I can run this. I can say simulate. So that's what it will look like. Okay, so this is what the observation, it says that this target is below the horizon, so it didn't observe it. I'm just running this. I can change the time to make it fit in.
Yeah.
But you see how the observation will go. So what I have shown you here, we prepared. This page is prepared by me, but he created the stuff. So I prepared this. You put in the duration for one scan. You don't want to observe for too long, and these durations are in seconds. Okay. So you move to the next source, you go back, you move to the next source. So this you would do. The observatory would just use this. If you prepared it badly, they will decline it. If you think you don't like it, you request them to decline it. They decline it, you modify it. So when they approve it, they will use it to run your observation. So you don't need to go there. You sit here and do everything you want to do.
Okay. Thank you for the response. And I think at this point, ladies and gentlemen, I think we have successfully come to the end of today's program. I thank you for being part of the program, and I hope that you will appear again whenever we invite you to appear. So thank you once again, and we call it a day. Thank you.
All right, thank you.
Thank you. Thank you.
Thank you, Prof.
Thank you.
Thank you, Prof.
Bye. Bye.
Bye-bye.
Ciao, ciao, ciao.
Thank you, professors. Thank you, professors, for your help.
Goodbye.